Welcome back to the channel, guys. This is Joseph from Moralis, and in this video, we're going to make a betting game dApp where two people needs to deposit money into the game, and a winner is chosen trustlessly on chain. The winner gets all the money, and the loser loses all the money. In this dApp, we'll be determining the winner by using Chainlink to generate some random number, but Chainlink can also be used to get real-world events data like politics, sports, and etc. to help you build a real prediction market dApp if you like to. So back to here, for this dApp, you'll be able to either create your own betting game or challenge other people's game, and the process is very simple right here. So here, as you can see, I'm on the dashboard and there are a bunch of betting games that have been created. And if I scroll down right here, as you can see, there's a bet button on one of the betting game, which I can just click to participate as a challenger of this particular game. And just click and a model pop-up will appear in front of me to play the game. But before we do that, we need to follow these several steps before we play the game. And the first one is to burn some bad tokens. So what's a bad token? Basically, it's a utility ERC20 token that we're going to create, and it can be used for building the dApp ecosystem for the token holders. In our case, the user will need some bad token to hold so it can be burned when creating or challenging the game. However, it is not in any way mandatory when building the dApp. It's just the way I design it. So then to continue, just approve and burn. And once the token is burned, we just join as a challenger on one of the game. And before playing the game, we'll deposit our ERC20 token. In this particular instance, we need to deposit some link tokens into the smart contract. The reason why we use another ERC20 token is because these tokens are more liquid and wanted by a lot more people than just any random token. Plus, deposit assets are going to be the prize for the winner, so it'll be something that people prefer to gain than just some random tokens that people don't want. Of course, Ether could also be one of the options for the deposit asset, but since it is a native token to the blockchain, it has a very different implementation to be depositing compared to using ERC20 token. So in this case, we didn't add that functionality in this tutorial because it will add more complexity to the smart contracts. Instead, if Ether were to be used for deposit asset, wrap Ether could be an alternative as it is an ERC20 token, and our smart contracts code will basically work automatically without needing to write additional codes. So before we deposit, make sure that you have the appropriate amount of link that have been written right down here. And once that's done, basically you can just click approve and deposit. Once that's done, we are going to play the game, and using Chainlink, it will randomly choose the winner. And the winner is determined by a really simple rule right here. Basically, if the random result of the creator and the challenger is added to be an even number like 2, 4, or 6, and etc., the creator will be the winner of the game. Otherwise, it'll be the challenger instead. So to do that, just click the Bet Now button here to play the game. And boom, once it's done, we just play the game and we can close the model here and wait for a few moments for the blockchain to choose the winner of the game. Once that's done, the winner will be able to withdraw all the deposit assets from the smart contract. So here I have an example of game that I've just won. So to withdraw the asset, basically I just need to click the withdraw button right down here and a MetaMask prompt will appear. And to withdraw, I can basically just click confirm, but at this moment I don't want to, so I can just reject it right now. You can of course be a creator of the games, and to do that basically just click this create game button and it'll be pretty much the same process as what we just demoed before from the challenger side. And that's what we'll be building, and we're going to learn how to build all this using Chainlink and Moralis. For those who never heard about Chainlink, in short, Chainlink is a decentralized Oracle protocol that can help us build smart contracts that'll be able to interact with real-world data. In our case, it is getting the price of ERC20 token to Ethereum in order to calculate how many ERC20 tokens do the player need to deposit based on real-time price of the tokens themselves. Another use case will be using the Chainlink VRF right here to generate some random number, because by default, blockchain is a deterministic machine, which makes it impossible to create any kind of randomness in the smart contracts. But with Chainlink, we'll be able to do that and build our betting game platform. And for those who are new to the channel, Moralis is a Web3 development platform that provides you with Web3 SDKs and backend infrastructure that can help you sync on-chain data real-time and instantly with the Moralis DB. And of course, this will work cross-chain by default. With Moralis, you don't need to build your own infrastructure and just focus 100% on developing your dApp. Also, we'll be using Ethereum Boilerplate right here, which is the best boilerplate out there if you want to build your dApp quickly because it integrates well with the Moralis SDK. Plus, if we scroll down here really quickly in the docs, you can see that the Moralis team have been working really hard to add a bunch of reusable components and hooks within the boilerplate itself, which you can just use out of the box without needing to redefine again and again in your dApps. And this will absolutely shorten your development time even further. Before we start developing, here's a simple outline for the video that we're going to do step by step. First, we'll do the environment setup, such as setting up Moralis server and cloning the repo. Then, we're going to learn how to write the betting game smart contract with Solidity. And third, we're going to create the ERC20 bet token and learn how to handle it in the smart contract. And next, we'll be integrating Chainlink to our smart contracts, such as the Chainlink price feeds and the Chainlink VRF. And then we're going to deploy those smart contracts that we've written to the blockchain. Then we'll continue on with the UI and integrating those smart contracts into our React dApp. Also, we're going to use event sync, Moralis DB, and Cloud Function to enhance our dApp further with some real-time blockchain data. And last but not least, we'll be hosting our finished dApp to the Moralis server so that others can see what we have built. As you can see here, you will learn so much from this video and it will undoubtedly change your life if you follow it from start to finish. It will be very easy to follow, and by the end of this video, you will be surprised of what you yourself have accomplished. So without further ado, let's start building our dApp. So before we start the development process of our DeFi betting platform, first we need to set up a few things. So one of the first things that we need to set up is that we need a free Moralis admin account. And to do that, basically go to moralis.io here, this page, and then you can sign up for a free account here. And if you don't have an account, you need to sign up first. It's gonna take a few minutes, but if you already have one, basically it will redirect you to this dashboard here. So once we're in this dashboard, we can create a new server for our dApp, a testnet server. So here I'm gonna choose it, Moralis betting platform or protocol server, and then select the region here, and then there's a bunch of Ethereum testnet network that we can choose. Basically, we're gonna choose the one where we're gonna deploy our smart contracts to. And in this case, I'm gonna deploy to Coven, Polygon Mumbai, and BSC testnet. But if you guys deploy into other testnet, just choose them. It doesn't really matter. So once that's done, you can click Add Instance, and a server will be created for you on your behalf. And it will take a few minutes, so just wait. But in my case, I already have one here, so I don't need to do that. And the next thing to do is clone the project here. This is my repository for the betting site that I just showed you earlier. So to do that, basically here, and don't worry, I will link the GitHub link in the description below, so you guys can follow. And here, basically, just clone the project here, copy the HTTPS link, and then open your terminal and go to any directory where you want to clone the project. And once you're there, you can just basically git clone and paste the project. So once that's done, then basically it's gonna take a while to clone the project, but after doing so, you can open VS Code. And here, let me open my VS Code for the project itself, and you'll have a bunch of files within the project itself. But of course, even though it's there, it's not ready yet for development because we need to set up a bunch of stuff still. So first thing, of course, you need to install the dependencies, and let me explain the file structure a bit here really quickly. Inside here, the src file, it's gonna be all the React related files here, and then in the second one, which is the truffle file, it's gonna store all the truffle related files. It's a truffle project inside the repository, basically where we can develop our smart contract and deploy it, write some migration script, and etc. And so we basically need to install dependencies on both. As you can see here, for the React app, the package.json is going to be on the root folder. So you just need to npm install, or if you like to use yarn, then just yarn, and it will install the dependencies. And for the truffle one, you need to go to the truffle project and then do the same thing, basically npm install or yarn it. And once that's done, basically you need to create a .env file here. I have it, but I'm not going to show you because this is going to be, there's some sensitive information within the file, but the structure is going to be basically like this, where there's going to be a React App Moralis application ID, React App Moralis server URL, Moralis API key, and Moralis API secret. Now, while this three information, is not very sensitive, this one, the Moralis API secret, is something that you need to keep private. So that's what the function of .env file in here is. So in order to get all this information, basically, you just need to go back to your Moralis admin here on the dashboard and go to your newly created server, view details, and there you go. There is the server URL here, application ID, and the Moralis API key will be this one, the CLI API key and the CLI API secret. Just copy all of this into each entry, and once that's done, basically you can copy the file and rename it as .env. And similarly, within the truffle project, there's also a .env file here. So this one have an Etherscan API key, Moralis Speedy Notes key, and archive. So let me explain really quickly what those are. So for Moralis, for the Etherscan API key, it's gonna be this one. There's also Polygon Scan API key, BSC Scan API key, and other stuff. Basically, these API keys here are for verifying the smart contract through our CLI, but this is optional. So if you would like to add them, feel free to, but if you don't, basically you cannot verify your smart contract through the CLI. But the important one is basically gonna be the Moralis Speedy Notes key and the .archive one here. So what are those? Basically, it refers to this Speedy Notes here. Let me show you in the Moralis admin. So if you go to the Speedy Notes section here, as you can see, there's a bunch of chains which you can connect to. And in here, if I take one example, there's gonna be the non-archive node and the archive node for each of these chains. So as you guys can see here, like the Speedy nodes always have some kind of format where in between there's gonna be this bunch of random number, and this is what I refer to as the Moralis Speedy nodes API key. So you can just basically copy this part and paste it into your .env file here. So just paste it, and archive should be either true or false. So it's up to you guys, but keep in mind that not every Speedy nodes have an archive node, but in our case, actually, we're gonna use Ethereum, Coven, Polygon Mumbai, and BSC testnet all have archive nodes. So yeah. So once that's done and set up, the last thing that we need is basically the mnemonics of your wallet. So in here, we're gonna put it in our .secret file. It's gonna be either 12 random words or 24 words based on your wallet. But if you forgot your wallet mnemonics, no worry, we can always generate one here. So to generate one, basically you just need to npx mnemonics on your truffle folder. So just do that and wait for a second, and it's gonna generate a new mnemonics for a new wallet and paste it, and then similarly just copy and rename it as .secret here. So once that's done, you need to you get a new wallet basically, but and this is gonna be used to deploy your smart contracts later. And in order to deploy smart contracts, you do need some native token. I mean, like Ethereum, you need some Ether, or maybe like in BSC testnet, you need to have a BNB. Polygon Mumbai, you need to have Matic tokens, but something like that. And in order to do that, you need to have the address. So let's check our address first. You need to do that. Basically, just yarn console network Coven. So in this example, I'm gonna check my Coven address. I'm not gonna copy this one because I already have my own mnemonics. So this one is basically from the console script here, which is using Truffle. So make sure that you have Truffle CLI within your system. And I can just enter here and wait for a moment while it's connecting to the Coven testnet. And once it's connected, then we can check what is the address of our account. It's going to be web3.eth.get accounts. So just press enter, and here you go. You're gonna get a bunch of address here, but the most important one that you need is gonna be the first one, because it's gonna be the address where you're gonna be using to fund deploying the smart contract. And to do so, basically just let's copy the address and check the balance here really quickly. Just paste it. And once that's done, and we can see the balance in Way. So this is, as I remember, it's approximately 0.5 ETH, and I think it's quite sufficient. But if you have 0, basically you just need to go into any Ethereum faucet or BSC faucet or Polygon faucet, and then copy your address and get some testnet, either BNB or Matic, so that you can fund your deploying your smart contracts. And yeah, so that's all the setup you need. And I'll see you in the next video, where we'll start developing our smart contract for the betting game. If you guys still have any questions regarding the DeFi betting platform we just built or the tutorial itself, make sure to go to this forum at forummoralis.io, and I'll put the forum link down in the description. And here we'll help you with your questions as soon as possible. Also, make sure to like and subscribe to our YouTube channel if you want to see more Web3 tutorials like this. Thank you guys so much for watching, and I'll see you guys soon. Bye bye. Welcome back to the channel, guys. And in this second video in the tutorial series, we'll be continuing on developing our DeFi betting platform using Moralis and Chainlink. And in this video, we're going to be focusing on developing our betting game smart contract. So before we start, if you already followed the instructions in the first video, you'll be having your repository clone within your local file, and after do that, just go to your truffle project here. So right now my root folder will be your truffle project, and don't forget to go to the empty project branch, because the main branch is going to be the one that filled with the full implementation of the dApp itself. So in this branch, we're going to start basically kind of from scratch. So, and also to find bettinggame.sol, basically go to under contracts, bettinggame.sol. So right now we want to implement the betting game smart contract. It's going to be a very simple implementation of a betting game where we'll be basically enable to user to basically register as a player and then deposit some ERC20 token and let the Chainlink VRF, as we mentioned, it's kind of like a random function to generate the outcome of the game. But to simplify the tutorial in this video, we'll not be implementing the ERC20 token and Chainlink part for the smart contracts, and we're gonna do it in the later part in the video series. So let's jump into it then. So right now it's not totally empty, but there are definitely some functions that we need to fill in to get the functionality that we want, and this is where we'll be filling all the logics that we want to implement so that we could have a betting game smart contract that we can integrate later with our React client app. So first thing first, let me explain some of the things that we have here, starting with the storage variables, which is this sections. So the first two are Chainlink related, so I'm gonna skip them for now. So starting with the third one here, we have a creator variable. It's gonna be a public address, public and address type here. So basically, someone who created the smart contract is gonna be the creator, and then the challenger is gonna be basically someone who bet against the creators themselves, and it's gonna be represented also by a public address type. And the sites, as I explained from the first section of the video, is gonna be like the number of sites on the dice is 6. So in this case, if the sites is 3, we're gonna the possible outcome is gonna be 1, 2, and 3. And this is also gonna be defined as a public variable as well in the form of UN256, which is basically an unsigned integer. And then the next one is gonna be the status of the game, because the game, in the case if both the creator and the challenger have played the game, we don't want anyone else to play the game. So we need some kind of restriction where like whether the game is still open or still closed. So, you know, give some restriction on whether one can still access the game or who can access the game or not. So in this case, it's gonna be the betting game status type, which is an enum that we define here. And as I mentioned before, it's gonna be open and close. Open basically means anyone can register as a challenger to bet against the creator, as long as the challenger is still an empty address, like no one has registered for a challenger. Otherwise, if both of the players have played, then it's gonna be close. So in this one, the next one is gonna be UN256 public variable, which is representing expiry time. Expiry time here is basically when the game has expired. Basically, it's the same as the game being closed, so no one can really access that game anymore. And so the expiry time is gonna be in the form of a Unix timestamp. Later I'll show you, but basically it's gonna be an integer representation of time itself in the smart contract. So the next one is gonna be a native token address, which is the bet token that I mentioned in the previous video as well. It's gonna be an ERC20 token that we're gonna deploy ourselves and then input it, set it into the native token address here, and it's gonna be an address type public address variable, so something like so. And then the next one is gonna be the deposit token address. This one is going to be the token address of the deposit asset, which is gonna be either Chainlink, Uniswap, or DAI stablecoin based on the demo that I showed you guys before. But of course, it could be any ERC20 token address. And then the address for this one is gonna be price converter address. This is gonna be something related to Chainlink, so I'll skip it for now too. So the next one is gonna be address public, which is the winner. So once both play the game, once the creator and the challenger play the game, basically a winner will be determined randomly and will be stored in this storage variable in the form of address public. So, and of course, like we want to know whether the winner has withdrawn their winning asset or not. So in this case, there's a Boolean public variable or is withdrawn, and just that simple. So yeah, and the next one, we have some mappings here. As you can see, there's this one is related to Chainlink as well, but this one is going to be the player bet record registry, which is where we'll store the player betting record. Like what's the role the random generate output from Chainlink is, and it's gonna be basically a mapping from address to uint256. So we'll see later more on that. So from this storage variables, we're gonna store some of the initialization in the constructor here. So we have a bunch of variables in the constructor that is gonna be passed down. So this 1, 2, 3, 4 are also Chainlink related, so we can skip it for now. And then the creator is gonna be stored in the creator for sure. The sites is gonna be stored in the sites. And as you can see here, initially the challenger is gonna be address 0, indicating that in the beginning there's only creator, and the challenger is gonna be filled later with a valid address that is not 0 address. And then the next one is going to be native token address, which we're going to pass by ourselves once we deploy the ERC20 token contracts, and the price converter address, which we're also going to pass down later, and the deposit token address. Initially, it's going to be 0 address as well, and will be determined once the creator first deposited their asset before playing the game later. And so that's the constructor here. So once all those are set up, these are just some bit of modifier to check whether, like, is it the creator or is it the creator and challenger, and here is the challenger position is still empty, otherwise it will revert and throw some error. And then also to check whether the game is expired or not, because we want to disable access for anyone to the game once the game has expired or the status has been closed. So yeah, and this one is also only not withdrawn, is pretty obvious, and only winner. So yeah, and here are the real implementation below for all the rest of the smart contracts. As you can see here, we have a bunch of function from getting get betting game info here, and then the challenge, the cancel betting game functionality, the play game, and then this is gonna be Chainlink related as well, which is gonna be connected to the play function, which we'll discuss later in some other videos. So the next one is gonna be deposit and withdraw, which is very obvious based on the demo that I did in the first video. So yeah, let's just start implementing each of this function then. So I make some comments here to make it really easy to implement. So basically, let's just start from this one. This is gonna be a getter function basically, where we want to get all the info of the betting game. So it's gonna be pretty straightforward here. I already make some comments to basically just fetch some of the info from the storage address up here. So let's just do that really quickly then. So in here, for get betting game info, it's gonna be returning this data structure, which is gonna be address, UN256, and etc. in the form of these variables. So let's just do that. So in Solidity, we're just gonna return it, and it's gonna be in brackets as well. Don't forget the semicolons. And then this is gonna be the creator, challenger, sites, status, expiry time, deposit token address, the winner, the is withdrawn variable, and then the creator's role and the challenger's role is gonna be this one, which I mentioned before. It's from the mapping. It's gonna be the result of the generally random outcome from Chainlink VRF, which is gonna be stored here. So as you can see, the address is gonna be either the creator or the challenger's address, and the UN256 is gonna be the randomly generated outcome for each of the address. So we can just use that. As you can see, this is the name is player bet record registry. Player bet record registry. And the first one is going to be for the creator. And the second one is going to be for the challenger. And there you go. Just that simple. So we just did our first function, a getter function, to get all the public info data for our betting game. So basically, we can use this function to call in our client app in fetching all the betting game info related to this particular betting game instances. So next one, we have another function here, which is the challenge. The challenge is basically when the challenger register their address into the smart contract. And as I mentioned, it's similar to when the creator create a game, they need to burn some tokens. But of course, in here, we'll not implement it at the moment because it's ERC20 token related. We're gonna do it in the next video. So in this one, we're gonna register the challenger. So to do that very easily, we're just gonna redefine our challenger here into msg.sender, which is, for those who don't know yet, msg.sender is basically the address that called the this particular function. So in this case, when a challenger wants to register as a challenger for this particular game, basically, if they call this functionality using MetaMask, they're gonna be the msg.sender, so challenger. So the other one is going to be where we'll be emitting the challenge event, which I have defined several events here related to some of the functions. So here we have challenge, play, deposit, and withdraw, which we're going to use later. And for now, we're just going to use challenger with the input as the challenger address itself. So we can just emit challenge, and there you go. So, and the challenger will definitely become the address of the emitted here in the event. So maybe here, let me change it into MSG sender instead, but both is fine, definitely. So there you go. So the challenge is basically where we will register challenger, and it's just that simple. Just make the challenger as the msg.sender, which is basically the address that calls this challenge function. And then the next one, we want to enable the creator to cancel the betting game itself. So in this instance, as you can see, it's going to be very simple as well, because we'll just be basically changing the status, the betting game status, from open to close. So in this case, let's just status equals to betting game status dot close. So oops, I'm saving it now. So just like that, and the betting game status is gonna be turned from open to close if the creator is calling this cancel function. So these are very simple implementation, as you can see. And for the play one, we're gonna implement it further later, because this is gonna be all Chainlink related. So the next one is gonna be deposit and withdraw. This is also the last two functions that we're going to implement. So both are gonna be very simple as well. So let's just do it here then. So the first one, as you can see here, the get price feeds is from Chainlink, so we're gonna skip that now. The transfer ERC20 token from user is gonna be skipped as well, because it's ERC20 token related. And this one is gonna be set the token address when it is empty. And when I mean by empty, it means when the address is still 0. So in here, let's implement the logic. When the deposit token address is still 0, we would like to set the deposit token address. Oops, my bad. This should be just 2 equal sign. So this one is going to be the deposit token address equals to the underscore token address, which is the one of the input of the deposit function here. So just give a semicolon here to close it, and there you go. You have set the deposit token address into another token address, which is basically an ERC20 token address. So great. Once that's done, the only thing we need to do other than that is emit the deposit event here. So to do that, we just need to input the token address. So it's going to be underscore token address and the token amount, which is also going to be something related to Chainlink. So for now, we're just gonna skip it to 0 here, just for simplicity, but it's not gonna be 0. So yeah, that's gonna be the deposit asset logic here. And then the next one is gonna be the withdraw one. The withdraw is also very simple. The transfer, so there are 3 steps here. So the transfer deposit asset is gonna be ERC20 tokens related. We're gonna skip it. And then in here, we're gonna withdraw our event here. So we're gonna uh, so we're gonna emit a withdraw event. So emit withdraw. The first one is gonna be the winner, which is the winner address, and then the token address is going to be the deposit token address. And the token amount, it should be something that is in here, which is not should be 0, but right now we're just gonna set it for 0 at the moment. And then the last one is gonna be defining the is withdrawn to false, because once the winner withdrawn the price, we don't want them to call withdraw again later. So is withdrawn is now gonna be false. Oh, I think this should not be false. This should be true instead. Yeah. Yeah, it should be true, because if the winner called the function, at first it's gonna be false, but then after it's withdrawn, we want to set it as true. So yeah, this should be the right implementation here. So this is gonna be the very basic implementation for the betting game smart contract. But in here, if we just define the betting game smart contract, basically there's just gonna be one smart contract, and they cannot really create another one unless we deploy it manually by ourselves. And in order for us to be able to create many betting game contract instances, basically we need to have something called a contract factory. Basically, it's a smart contract that can be called to create another smart contract. And in this case, it's gonna be the betting game registry contract here, which I also have under the betting folder beside the betting game. That's all. So this betting game registry contract is gonna be the one that we'll be using to create multiple betting game instances for our application. But also, since it's a registry, it's gonna be the one that's gonna keep track of all the betting game that is created and etc. So here, as you can see, the betting game has several inputs in the constructor, and we'll need to input some of them in the betting game registry later. So first, let me explain some of the functionality within this betting game registry as well. Basically, in here, let's see, the native token address is very similar. It's going to be the ERC20 bet token address, which we'll define later. And then the price converter, we can skip it now. This skip. And the betting game count is going to be something to keep track, like how much betting game contract that has been created from the client app, something like so. And in this case, I'm gonna make it a private variable. It's gonna be UN256, but if you want to make it public as well, it doesn't really matter. And then the other important thing is gonna be the betting game data registry, which gonna register and track all the betting game that has been created from this betting game registry contract. So the data structure for this one is gonna be a mapping public one. It's gonna map from UN256 to an address, and this address is gonna be basically the betting game address of the address of the betting game created by the betting game registry. And in here, to create the betting game, we have a special function here where we're gonna create the game. And yeah, basically that's where we'll create the betting game smart contract, a new betting game smart contract for the user, and also keep track of all the betting game that has been created. And of course, as I mentioned before, there's gonna be some token burnings, but we're gonna skip it for now. So yeah, and other functions, there's also betting game ID and set native token address, which are very intuitive. So this is basically gonna be getting get betting game ID based on the betting game number here, which is from the betting game registry here. And this one is gonna be set native token address in case if we are deploying another ERC20 token and we want to change the native token address into a new one, then we can do that. And of course, this is only owner, the one that deployed the smart contract, can do this functionality. So yeah, let's just start and do that then. It's gonna be very simple as well. So this one, the get betting game ID, is gonna be a getter function. It's just going to read some of the storage variables similarly as the one we have in the betting game smart contract before. And here, so we're just gonna return one input here, which is an address. Basically, it's gonna be the address of the betting game smart contract that is created on a certain ID that we have. So it's gonna be betting game data registry, and the input here is gonna be betting game ID, which is gonna be the UN256. So once that's done, just this one at the semicolon, don't forget, and there you go. So this will enable anyone to get betting game address using a certain betting game ID. So the next one is gonna be set native token address. It's very straightforward as well, just one line. So in here, we're just gonna rewrite the native token address into a new native token address. And there you go. Very simple. So these are just very basic implementation. Of course, there might be more complicated logic to handle some access control, but this is what we have now. And the last one is gonna be the create game functionality, which is the main function that we'll be using to create multiple betting game smart contracts. So to do that, here we're gonna skip the burn token part. So here, let's create a new betting game, and in order to do that, we can easily just so it's gonna be betting game. So and then new betting game. This is, and then we're just gonna new betting game. Betting game is basically the type from the smart contracts here, because we have imported the smart contract betting game.sol into the betting game registry.sol here, so we can use the smart contract as a type. And here we're defining betting game, new betting game equals new betting game instance, which will create our betting game, new betting game smart contract. So in this will be new betting game, and we'll be looking at our constructor here because we need to pass down some variables. So in here, there are a bunch of variables here, which we'll just pass down. So let's not remember that and just copy it for simplicity. So in here, then we basically just need to replace each of these variables for to create the new betting game smart contract using this create game function. So here, the VRF coordinator address is gonna be the one up here. So basically, we have each of this. This is the Chainlink related stuff, but we're just gonna pass it down for now. So key hash without the underscore. Most of this I just define it without underscore for the storage variables, and for the memory variables used in the functions, it's gonna be with the underscore. So the side is gonna be this one, the UN256. So just underscore sites, and the native token address is going to be the storage variable here. The native token address, it's gonna be in here. So, and the price converter address similarly. So there you go. Let's just add a semicolon and save it. And there you go. Oh, the creator. Do we need to pass the creator? I forgot. Seems like so. So for the creator, it's gonna be msg.sender, which is basically the one who called the smart contract. So yeah, there you go. Now with this line of code, basically we'll be able to generate multiple betting game contract instances by calling just this create game function from the betting game registry smart contract. And once that's done, basically here, let's emit the create betting game created event here. So in here, it's going to be the betting game ID is going to be the last count, the betting game count. So we're gonna increment this betting game count every time a new betting game instance has been created. Oh, and I almost forgot, but we also need to register this betting game instance into the betting game data registry with the latest betting game count. And this is gonna be the address of the new betting game. So by wrapping this with address new betting game, we'll be able to get the address of the newly created betting game smart contract and register it into the betting game data registry with the index of the latest betting game count. So once that's done, we'll emit the betting game created with the betting game ID, which is the latest betting game count, and then the creator is gonna be msg.sender. The sites is gonna be underscore sites from the input here, and the betting game address is going to be basically this one. So address new betting game address new betting game. There you go. Yeah, so just that simple. And the last step is going to be increasing our betting game counter, because of course it's basically to indicate that number of betting game that has been registered has increased. So here for the betting game count, we just gonna redefine it into betting game count equals 2. So in this instance, instead of just adding 1 like that, we're gonna use a library from OpenZeppelin here, OpenZeppelin contracts utils math save math to avoid from some problem in the smart contract, because there's sometimes overloading when when doing arithmetic in smart contracts. Like we could do this, but sometimes it could be dangerous when it's overloaded. So in order to avoid that, because it could also throw some nasty error and maybe some hacking in the worst case scenario. So here we're gonna add safemath dot add, and we're going to add the latest game count with 1. So basically, uh, it's gonna be pretty much the same as betting game count plus 1, but this way it's gonna be much safer to avoid some of those problems that I mentioned before. So yeah, basically that's gonna be the implementation of the betting game registry, and in this way we have right now we already have a basic implementation for the betting game smart contract. As you can see, it's very simple. It's not so complicated in this case. Of course, this is not production grade, so don't just copy it and deploy it. You need to still check with some smart contract audits. But yeah, with this, we'll be able to have a betting game smart contract, and we'll be able to create those betting game smart contract over and over again through the betting game registry, which will track all the created betting game smart contracts. And yeah, so that's it for this tutorial. In the next tutorial, we'll be implementing some ERC20 token functionality where we'll be able to burn, deposit, and withdraw the any ERC20 token from our smart contract or to our smart contract. So I'll see you guys in the next video. Thank you guys so much for watching. If you guys still have any questions regarding the DeFi betting platform we just built or the tutorial itself, make sure to go to this forum at forummoralis.io, and I'll put the forum link down in the description, and here we'll help you with your questions as soon as possible. Also, make sure to like and subscribe to our YouTube channel if you want to see more Web3 tutorials like this. Thank you guys so much for watching, and I'll see you guys soon. Bye bye. Welcome back to the channel, guys, and in this third video in the tutorial series, we're going to learn about ERC20 tokens and how to handle them in our smart contracts to further build our DeFi betting platform. So for those who don't know what's an ERC20 token, basically it's a fungible token, and it's based on the EIP20 token standard that was defined years ago by Fabian Vogelsteller and Vitalik Buterin, which is the co-founder of Ethereum itself. And this is basically an EIP is basically a proposal that was made as an improvement on the Ethereum network itself. So you guys can check, there's a lot of EIPs, and one of it is this one, EIP20, where they basically define what's the standard for fungible tokens. So the keyword here is fungible, and it's very important because there's fungible tokens such as ERC20 tokens, and there's also non-fungible tokens such as ERC721 or ERC1155. And fungibility means that like $1 equal $1. So both have the same value, and they can be exchanged on the basis of the same value. And this could not just be any currency, but could also be voting power and any other implementation. So basically, in here, ERC20 token, it's basically just a smart contract that is defined with certain types of functions ingrained within the code themselves. And as you can see here, some of the functions or methods that are defined, that need to be defined for a smart contract to be an ERC20 token, are name, symbol, decimals. These are optionals though, as you can see. And then the total supply, balance of transfer from, and this other function that they have here. And also, of course, there must be define some specific events, such as when transferring, we need to emit some transfer event, and when doing an approval, we will need to emit an approval event. And yeah, so although these are a lot, but luckily OpenZeppelin already provided us with a library to implement ERC20 token out of the box, so we don't need to do it from scratch here. Like as you can see here, I already have an ERC20 token smart contract. So in this case, we'll just be using an OpenZeppelin library contracts. And here I am importing the ERC20.sol library, which I'm going to include into an example of my token here. And by the way, in here, I'm going to use Remix in this tutorial for a moment, because ERC20 tokens could be quite complicated, especially when handled in smart contracts for beginners. So it's best to test it out and show you guys how ERC20 tokens really work directly on the smart contracts when it is deployed. So in here, basically, I have my token contract, which inherits an ERC20 token contract from the OpenZeppelin contracts, and also the ERC20 burnable contracts from OpenZeppelin as well. And this ownable is basically just means that only the owner will have access to all this functionality. But basically, when when my token contract inherits the ERC20 token contract, basically all these functions will be included within the smart contract without us needing to define it directly. So yeah, it's very simple. And the burnable one is basically that means that now we also have a burning function, so that we can implement some burning mechanism into our smart contract. But of course, it's optional. It's not something that every contract will have. But in our case, because our dApp needs to burn some tokens in the process of creating the game, as I show you in the demo, we do need this ERC20 burnable contract to be inherited by this my token smart contract. So in here, as you can see, the constructor doesn't do anything except just initializing the ERC20 token instances for this my token. So the my token is going to be the name here. So in this case, they don't actually have the name, but if we define the name, it's gonna be returning this one, a string of the name here, my token, and the symbol is gonna be mtk. And there's one method function here that I defined, which is a minting function. And in here, basically, it just needs to address input and the amount in UN256. So how much ERC20 token that we want to mint to which address to be minted. And this can, as you can see, only be accessed by the owner, which is basically the one who deployed the smart contract itself. And it's gonna call an internal mint function here, which basically works the same, but it's a private function, so we cannot call it directly. So this minting function is a public one, which can be called by anyone, but in this case, it's only restricted to only owner. So to test it out, let's deploy the smart contract. Let me compile this for a moment. And this time, I'm just gonna use a JavaScript VM here, or maybe let's just use an injected Web3 so that we can see it in Etherscan. So now I'm connected to my MetaMask. So here I'm gonna be on the Coven test network to test it out. So let's just deploy our smart contract then for a moment. So this ERC20 token is gonna be this one. Oops, maybe not that one. It's gonna be this one, the my token contract, as you can see. So just like that, and deploy. And using Remix, it's gonna make everything for deploying very easy. So here I just need to confirm to pay the deploying gas fees. And in a moment, it's gonna list our deployed contracts in here. As you can see, it's very quick. So there you go. And as I mentioned before, we have, although we just defined this one method function and a constructor here, because of the ERC20 and ERC20 burnable that we inherit, they include a bunch of other functions that are defined in the EIP20 token standard that I mentioned here before, as you guys can see here. So here, as you guys can see, if I click the name here, I'll get my token. The owner will be, of course, my own address here, as you can see. And the symbol will be the symbol of this MTK. And other things is probably like the decimals that we would like to know is going to be by default is 18. And the total supply is, at the moment, it's going to be 0 because we haven't minted any tokens yet. So yeah, without further ado, let's mint some tokens and include it into our MetaMask. So to do this, first let's mint some tokens into our address. So to do that really quickly, just copy my address here. And then we would like to mint, say, maybe one my token tokens. So it's gonna be, since take note that since this is having 18 decimals, so in this case it must be 1 times 10 to the power of 18. So there must be 18 zeros here. So 1 2 3 1 2 3 1 2 3. So there you go. There should be 18 zeros right here now. So if I mint it, it should be sending about one my tokens into my address, which is this one. And we'll be able to see that in the Etherscan because this is on the COVID network. So just transact that and confirm. And just gonna take a moment here. As you can see, it's pending. And once that's done, we can check on Etherscan. Just wait a moment here. It's still loading. But yeah, so should be, this is the transaction details for the minting transaction itself. And there you go. And as you guys can see here, basically, I'm calling the address of this, what's that? The ERC20 token here. Let me see. Yeah, it's gonna be this 0xBC. And this one as well. This is gonna be the ERC20 token smart contract that we just minted. And as you can see here, I just called the mint method function about 45 seconds ago. So right now, if I go to my MetaMask here, of course, you will not see anything on my balance, but that doesn't mean that we didn't mint it successfully. We just need to import the assets into our MetaMask. So to do that really quickly, let's just copy the contract address here and import tokens and paste it. And then there you go. It's gonna complete all the token symbols and decimals part and add custom tokens, and there you go. We have one MTK token within our MetaMask. So yeah, so that's the minting functionality, but that's just the really simple part. The one that we really want to focus on for our smart contract, the betting game smart contract here, let me show you guys, are going to be depositing functionality, which is basically transferring ERC20 tokens from the user wallet to the smart contract, to the betting game smart contract. And also in here, I'm sorry, it's gonna be transferring the deposit asset the other way around from the smart contract to the user wallet themselves. And another one will be, of course, burning the tokens that they already explained. So let's focus on trying to implement both burning the tokens and transferring the ERC20 tokens uh, within Remix themselves. So here I'm back at Remix right now, and now if you guys might took a glance before, as you guys can see here, there's actually for burning and for transferring, there are two functions, and this could get pretty confusing, especially for beginners. So let me explain a bit what they are. So basically, an easy way to remember is that uh, when a contract calls burn or transfer without any from within the method name, basically it means that they are burning or transferring the tokens within its own smart contract. But when it is burning from or transferring from, that means like the smart contract is getting access from a user wallet or possibly other smart contract, the fund, the ERC20 token from the other smart contract or user address. And that's basically the difference. So the one without the from is going to be accessing the fund within its own smart contract. The burn from and the transfer from is going to be accessing funds uh, outside the smart contract that executing this method themselves. So but of course, because this burn from and transfer from needs to access ERC20 tokens outside of their own permission, like the one that's not belonging to them, it means that they need to be first approved by the contract or the user address that's going to uh, uh, that's uh, that's going to call the burn from and the transfer from the smart contract itself. Basically, approve is basically uh, meaning like giving access to, as you can see here, the spender, which is the smart contract that is wanting to access the fund uh, about how much amount they want to basically burn or transfer the fund from their wallet to other addresses. So this is a lot of explaining. Instead of more explaining, let's just try to do a really simple contract here, which I have defined here, and test ERC20 contract here. And here basically we're gonna be accessing our the ERC20 token that we just deployed just now, which is this one. So let's copy the contract address here, and it's gonna be an ERC20 token address. Oh, I mean, this is gonna be the input. So we don't need to hard code it. Let's just deploy this first. So I compiled it, the test erc20.sol, and then once that's done, we can deploy it to Cova network, which is going to be this one. And to deploy here, as you can see, there is the ERC20 token address input, one of the input from the constructor that we need to define. Otherwise, the deployment will not be successful, and this is gonna be the ERC20 token address of the ERC20 that we just deployed before. So copy, paste, and transact, and there will be a MetaMask prompt to deploy it again. So yeah, it's gonna take a moment, and it should appear below here in just a second. Yep, there you go. So we have the my token, which is the ERC20 contract, and the test ERC20 contract is where we're going to test the burning and transfer functionality that I just explained before. So to do that very easily here, let's just let me explain a bit more what this contract does. Basically, in here we import the OpenZeppelin ERC20, and here the OpenZeppelin save ERC20.sol. So here is an ERC20. It's different than the ERC20.sol that we imported when we're implementing our ERC20 token implementation. Basically, this is an interface, and we need interface here. We need an interface here basically in order to call a deployed smart contract, because basically in our case we want to interact with an existing ERC20 tokens smart contract that has been deployed. In this case, this my token contract address within our smart contract itself. So to do that, basically we need to define ERC20 burnable to include the burn and burn from functionality. And this is just going to be very similar to any contract implementation without any of the real coding functionality. But basically here, the interface is just to let the smart contract within here to know what kind of functionality does the contract instance have. So in here, as you can see, in the constructor, I define token equals to ERC20 burnable of the ERC20 token address, which is this address here, the my token address that I inputted for deployment. So in this case, the token, the smart contract themselves will probably don't even know that this is a smart contract instance. So we use this ERC20 burnable that we define, and it inherits also the ERC20 implementation to know that there are the burn from method function, and also the save transfer from function, and also the transfer function here. My bad. So yeah, and here similarly as save mat, we're gonna be using save ERC20 for the ERC20 burnable, basically to implement a more safe and secure implementation for the transfer function, because we basically don't want our smart contracts to be hacked easily. There are definitely some flaws in the ERC20 token implementation, the original one. So we want to avoid that by using a safe ERC20 library. It's also included by the OpenZeppelin contract, so we don't need to deal with all the implementation. We just need to import it. So yeah, and here, as you can see, I already defined burn, deposit, withdraw, which is basically to mimic what we have on the betting game smart contract. And later we can if this is right, we can just copy this into our smart contract betting game smart contracts later. So without talking more, let's just try to test it out here. So as you can see here, the first one we're gonna try is gonna be the burn function. It's basically gonna call the token here and use the burn from, and it's gonna burn the token from the msg.sender, which is the the contract address or the user address that's going to call this burn method function, which is in this case gonna be my wallet address. And then the the second the second input is gonna be the amount of token that is going to be burned. So in this case, it's going to be 0.01 times 10 to the 18 way, which is equals to 0.01 my token. So yeah, let's just test it out really quickly. But as you guys can see, as you remember, the burn from needs some approval, but in this case we didn't give any, so it's gonna be failing as expected. As you guys can see here, guess estimation eroded with the following message: the transaction execution will likely to fail. And it is expected, as we mentioned before, because we didn't set any allowance for the smart contract to burn, to have access to the fund within our MetaMask here. So confirm, and it's gonna fail below. So just to understand. So there you go. It fails as expected, but not to worry. This is the reason is because right now the allowance for this smart contract, the test ERC20 smart contract, is 0. Let me show you here. Go to the allowance function. And the owner is going to be my address right now. The owner of the owner is going to be the owner of the token, which is me here. So I'm going to copy my address, and then the spender is going to be this one, the test ERC20 contract, because that contract is the one that want to have access to burn my my MTK token. So in order to allow it to burn the token within our address, they need to basically have an approval. But here, if we call, they have only 0 allowance on our address, so that means that they don't have any access to our funds at all. And to do that, to fix that pretty quickly, basically we just need to approve it here. We need to approve the spender, which is basically the test ERC20 contract address, and we'll be giving the amount to be 0.01 MTK, which is going to be 10 to the power of 16. So let me just do that really quickly. So there we go. Now it's going to have access of 0.01 MTK to burn on my on my wallet address. So first, to do that, let's just approve this first. Once it's approved, you need to pay a bit of gas fees there. And then let's check our allowance after it's confirmed really quickly. There you go. So let's call it again, and there you go. This time it's not 0, which means that the test ERC smart contract will have 0.01 MTK access within our user wallet, within my user wallet. So once that's done, this time the burning functionality should be working correctly. So let's just try to do that. And yes, seems like it's successful. And confirm. And just wait for a moment. And we should see that our MTK getting deducted 0.01. And as you can see there, it's successful. So yeah, that's great. We just implemented the burn functionality from a smart contract. So congratulations. So it's basically very simple, but we need to have this understanding of who owns the contract and who have access to whose fund. Otherwise, it could be very confusing, especially if we are trying to implement them directly into our betting game smart contract. So this is just to simplify. So the other functionality that we want is going to be the deposit and the withdraw. So the first one, deposit, is going to be safe transfer from, because we want to have this smart contract to have access, you see, to have access from our fund, which is the msg.sender, to to transfer the fund from this one to the to address of this, which is basically the address of this test ERC20 smart contract implementation. And it's also going to be 0.01. And similarly, if you try to do that directly, it's going to be failing because it's transfer from, it needs some allowance. But as you guys, I almost forgot to mention, once there's a transfer burn from method is called, basically the allowance is going to be deducted from it, so it's going to be going back to 0. So in order to do another uh, transfer or burning, we basically need to approve another transaction, something like so, for transfer or burning again. So to do that, let's just approve it really quickly again for the test ERC20 token smart contract. So let's transact and confirm, and we'll just wait for a few moments. Oh, there you go. It's already successful. So once that's done, this time our allowance should be 0.01 MTK again, because we just approved it. And this time we'll be able to deposit our MTKs, our MTK into the test ERC20 smart contract. And here, let me just deposit, and seems like there's no error, so it should be good. And just wait for a moment here, and let us also copy this one to confirm that everything's really working. So I'm going to Kofun Etherscan to check on the test ERC20 smart contract just now. So this is basically a history of our transaction. As you can see, we try to burn, and deposit, but those are failing. The second one is burn, is successful, and let us see the deposit. There should be another one here. So there you go. We just transacted like 34 seconds ago. Right now, it's still running the deposit on the background, but basically in a moment we should be able to see the ERC20 token balance within the smart contract of 0.01 MTK. And as you guys can see here, there you go, 0.01 MTK for the address that it's there because we deposited from our user wallet address. And if we go back to our wallet in MetaMask here, as you can see, it has been deducted another 0.01 MTK from our wallet, and it has been deposited into this smart contract, this test ERC20 smart contract. So the deposit is successful, and that's gonna be how we'll be implementing the deposit functionality within our betting game smart contract. And the last one is very easy, gonna be withdraw. And this time, as I mentioned, uh, it has no from in the method call. So basically, it's gonna be accessing the fund within its own smart contract. So in this case, since it's accessing its own fund, it doesn't need to approve. We don't need to approve or give allowance to the smart contract. We could just call the function this time, and in a moment 0.01 MTK token is gonna be coming back to our MetaMask wallet, as we shall see. So let's just withdraw that and confirm. And once that's done, we shall wait for a bit here. It's gonna take a while, so don't worry. So there you go, 0.99 MTK, and it basically, the fund comes back to our wallet. And if we check the contract address in Coven Etherscan here, basically it's gonna disappear right now. It's gonna take a while, so don't worry about it. There you go, it disappears because we just withdraw our fund from the smart contract back to our Ethereum wallet. So there you go. Basically, these are the implementation of the smart contract that we are going to use into our smart contract. So here, I believe that there should be a safe transfer functionality as well from the safe ERC20, which I almost forgot. So let's just try to do that as well. And we need to compile it again basically and try to deploy this one again, but with a different smart contract. So but it's gonna be using the same token. So let's just try to do that really quickly to test out the safe transfer. So this one is going to be test ERC20. Just input the address and deploy. And once that's done, confirm. And first thing, basically, let's send some MTK token into the smart contract. So let's copy that address. So this is basically a new test ERC20 smart contract address. It's basically a different address than the one that we have just now. In this case, let's just send it really quickly to test the withdraw. So it's gonna be 0.01 MTK. Then go to next, and then just confirm it. And then in a moment we should be seeing the balance of the smart contract, the test ERC20 smart contract, to be not zero, basically to be 0.01 MTK. So let me just test it out in here without going to Etherscan, the balance of, basically to check the balance of any address there is. So let's just call it here, and there you go. This should be 0.01 MTK in way. So there should be a fund to withdraw from the smart contract, so we don't need to worry of any error. So let's try to withdraw this fund back into our wallet then, because basically we just send our MTK, so there should be 0.98 again. But once we withdraw, it will basically come back to our our MetaMask wallet again. So it's gonna be 0.99 MTK. But this time, the only difference is that we're going to use safe transfer. And then confirm. So the transaction is confirmed. And when we check back, boom, there you go. 0.99 MTK back into our wallet. So yeah, seems like everything is working fine for the ERC20 implementation in the smart contract. So to do that, let's just copy each of this line here. So let's just copy this. Okay guys, sorry that I just jumped for the video from copying it, because it take some time, quite a while, and basically it's just implementing a very similar code from the one we have from Remix to our betting game.sol and betting game registry.sol too. So basically here, I'm just going to explain a bit what I added for the ERC20 token implementation in our smart contract. So here, the first one is the challenge method function here, where we basically uh, burn some tokens here. And as you can see, it's gonna be doing pretty much the same. It's gonna define the token as an IERC20 burnable interface here and calling it by using the native token address, because we want to burn the native token bet address, as you remember. And from there, basically, this token variable is going to be the smart contract implementation of the bet ERC20 token address that we had. And in here, similarly, since we want to burn it, basically we will do a burn from here, burn from the msg.sender, which is going to be the address that's going to call this challenge method function, and the amount that is going to be burned. It's a bit different here, but it's going to be 0.01 bet token times the number of sites. And in this case, we want it to be like this because as the number of sites increase, we want the challenger and the creator to burn more of their tokens. So yeah, and I'm using the SafeMath .mul, which is a multiplication implementation from the SafeMath library. So yeah, this is gonna be the burning token implementation within the challenge method function. Similarly in the create game as well, because when the creator is creating a new betting game, they will also burn some tokens. So in here, we do very similar things where we're gonna call the native token address into the token variables and then burn from the msg.sender, and it's gonna be the same amount of bet token that is going to be burned based on the number of sites that the creator can choose in this case, but the challenger cannot. So the other one is gonna be the deposit one. The deposit is basically just gonna implement a transfer from the msg.sender user address to the address of this betting game smart contract, and the amount this time it's not gonna be 0, but because it's gonna be depending on the price feeds from Chainlink, which we're gonna do in the next video. So this time we're just gonna put 0 into this one. And the last one is gonna be the withdraw, which is the reverse of the transfer from, because this is a transfer implementation. That means that it's going to access the ERC20 token within the smart contract, the ERC20 token within the betting game smart contract itself. So they don't need any approval. We just need to, the winner basically can just call this function without any approval, and it will basically transfer the fund from the msg.sender to the balance. Transfer from this betting game smart contract to the msg.sender with the total amount of the ERC20 token. As you can see, the balance of this address. So basically, when withdrawing, the winner is basically gonna take all the ERC20 token within the betting game smart contract. And there you go. And I almost forgot here. Let's implement a safe transfer as well. And this one is going to be safe transfer form. So this transfer implementation all can be much safer and not prone to any types of smart contracts hacking. So thank you guys so much for watching. This is gonna be the video for the ERC20 implementation into our betting game.sol. And in the next video, we're gonna be focusing on implementing the Chainlink implementation of our smart contract. And we're going to be using Remix again as an example. So stay tuned and hope to see you guys again soon. If you guys still have any questions regarding the DeFi betting platform we just built or the tutorial itself, make sure to go to this forum at forummoralis.io, and I'll put the forum link down in the description, and here we'll help you with your questions as soon as possible. Also, make sure to like and subscribe to our YouTube channel if you want to see more Web3 tutorials like this. Thank you guys so much for watching, and I'll see you guys soon. Bye bye. So for those who don't know yet, Chainlink is basically a decentralized Oracle protocol that help us give access to our smart contracts to access real-world data and services, and that will definitely help us to build a smart contract that can interact with real-world data, or basically use real-world data as a basis of the functionality of our smart contract. And from Chainlink, basically there's a bunch of functionality that can be used out of the box. Like as you can see here, they have data feeds, price data feeds to get some token prices in ETH or USD, and then VRF, as I mentioned, which is to generate random numbers within the smart contracts. And then they also have external APIs and Chainlink keepers, but we're not gonna use those. We're just gonna be focusing on this two main component of Chainlink within the smart contract. So let's get into it. The first one is gonna be data feeds. It's gonna be very simple. Basically, using the data feeds, we basically will be able to retrieve the latest asset prices, any asset price from our smart contract. And this is basically just a really simple getter function here. It's gonna be in this page for the EVM. They also available on Solana and Terra, but we're just gonna use the EVM one for Coven. So here, as you can see, they already have some codes here to provide us for getting the latest price of any asset to USD and ETH, or like BNB and Polygon Mumbai, like Matic token if it's on the other EVM blockchains. But basically, in this case, we can just copy this code and use them to directly get the latest price with this get latest price method function easily. So we don't need to do anything. They already build it for us, and here we can just use it in Remix to test it out really quickly. So let's check it out to see how to use it in smart contracts. So there you go. This is the smart contract for the price consumer, which is basically a smart contract that enables us to get the latest price feeds for any token asset we want. And this is basically prices that are aggregated from various different exchanges, so you don't need to worry about fluctuations based on one exchanges, because it's all aggregated. And we basically don't need to do anything other than providing the aggregator interface address here. Basically, this aggregator address, we can get it from, for example, for Ethereum data feeds, because we're going to take an example of Coven. It's going to be in here. Hang on a sec. There you go. We have Ethereum mainnet, and then below here it should be Coven. Yep, it should be Coven here. And in this case, these are basically the addresses that we need to input here to the aggregator v3 interface. So using this later, it's gonna be stored into the price feed storage variable in here. It's gonna be internal, so no one can access it other than the smart contract itself. And in the get latest price method function in here, we can get the latest round data basically by pricefeed.latest round data, and then destructure uh, the output. So we get round ID, price, start at, and a bunch of others. But we just need the price here, so we're gonna return the price. So let's just try it out really quickly. And in this example, we're gonna use uh, the one ETH to USD aggregator. So if we check here, it's gonna be 0x932. It's gonna be the same one as the ETH USD. Of course, there are others as well, which we can try later. So as you can see, it's the same address. But for now, let's just test this out really quickly. So let's compile this code. Okay, sorry guys, it takes quite a while to configure what's happening there, but now I managed to compile it. There are some warnings, but not to worry. It's just because we don't really need to use this variable. Of course, we can just remove them, but to be really quick, let's get to here and compile and deploy the price consumer fee tree one, the smart contract here, to get the latest price. So just deploy really quickly. Oops, seems like it's using the JavaScript EVM. We need the injected EVM because this is going to be interacting with a real smart contract for the ETH USD aggregator. So let's deploy it. And we need to pay some gas fees from MetaMask. And in a moment, we're going to have the price consumer smart contract below here. And there you go. So as you can see, we have the get latest price, and when we click the get latest price, because this is just a getter view function, it's not gonna cost any gas fees at all. So here, as you can see, just like that, and I already get the latest price of Ethereum to USD. So this one is using 8 decimal places, as you can see. So yeah, so this one is basically based on 8 decimals, so keep that in mind. Some of the other one is gonna be 18 decimals, so some are gonna be larger numbers than the other, but yeah, it seems to be correct because it's 4,000 for Ethereum right now. So yeah, but right now we only can get some of the prices from one token asset to either Ethereum and USD here, as you can see, which is very limited. And we actually in our dApp, what we want is actually the other way around. We want to convert ETH to the other assets, such as Ethereum to Link or Ethereum to Uniswap. Here they don't actually have one, and Ethereum to DAI, but basically it's gonna be the other way around, and unfortunately they don't have the aggregator address for those. But not to worry, because actually we can do that by converting the prices using the smart contract here. As you can see, the price converter, and as you can see here, in order to get a different price from one token to another token or another currency, we can just use this in case like we want to convert from BTC to euros, but we only have the aggregator interface from Chainlink from BTC USD and Euro USD. We can just basically take one and divide them with the other one and get the conversion price basically. So really quickly as well, we can just use this code and copy it. It doesn't have the remix button, but as I remember, I already copied the code somewhere around here, which we can just use here. There you go. And basically now there's a lot of code here, but you don't need to pay attention to most of them. As you can see, this scale price is also just internal pure, so you cannot call it anyway. The only function that you need to focus on is this get derived price, and it's gonna return a integer 256, and the first input is gonna be the base address, the base aggregator address, basically what's gonna be on top of this formula, and then the other one is gonna be the quote address, which is uh, the converted currency that we want to have. Like this one is Euro USD, so we need those that is gonna be the quote aggregator address that we need to be inputting. And the decimals is quite intuitive. It's basically how much decimals we want the output to be. It could be 8, could be 18, but regardless, it's on our own choice. But in our case, because we're gonna use it to interact with our smart contract, basically, it's best to just use 18. And also, we don't need to worry about the different 8 and 18 decimals between the base and quote, because in here actually they already handle everything for us. So to test it out, let's just compile it. Here I already compile it here. Let's do that again. And here, let's just use the price converter really quickly and deploy the smart contract. Yes, we don't need any other input. So deploy and confirm. And in a moment, we're going to get a price converter. So there you go. So in this case, for example, we want, suppose, ETH to link. So yeah, let's just try to test that out instead of link to ETH. So this is basically gonna be the reverse of what the price feeds aggregator address provided us. But so we just need to find the right pair. As I remember, we can do that by using link USD and Ethereum USD. Ethereum USD, yeah, this one. So let's just do that then. So it's gonna be from Ethereum to link. So let's copy this one as the base address. And then this one, the link USD, is going to be the quote address. And the decimal is gonna be 18. So yeah, let's just call it really quickly. And there you go, we have the price. I'm not very sure because it's gonna be in way and decimals 18. So let's just check really quickly. ETH to link price here. So in CoinGecko, seems like they have something here, and it's about 162.93. Link seems like the number is quite right. It's quite close. It's not going to be exactly the same because it's aggregating from different exchanges, but seems pretty close. So pretty accurate, and yeah, seems like it's successful. So basically, yeah, that's what we're going to need the price feeds for converting from Ethereum to Link and Ethereum to Uni. Oops. And Ethereum to DAI. Basically, the position where we're gonna use this is gonna be the deposit, where we want the deposit amount is gonna be based on the number of sites of that was chosen by the creator for the game. So suppose like if it's gonna be one site, it's gonna be 0.01 Ethereum, and we're gonna convert it, and it's gonna be how much deposit asset that the user need to deposit. And if there's two sides, we're just basically going to multiply by 2, and it's going to convert it to link, Uniswap, or DAI. So yeah, just that's it. Here, if we go really quickly to my VS Code, actually, I already have the price converter here. Oops, seems like I emptied it out, but no worries, we can just copy this. And use it directly here. So not to worry. So once that's done, we can basically use it in our betting game. We need to first import the price converter, and I did that also because we're basically going to use the price convert smart contract that is going to be deployed later within our smart contract. We also need to basically build an interface here, basically to define this what the function is going to be like. It's basically telling the betting game smart contract what function is available within the price converter smart contract instances. And in this case, it's going to have the get derived price with these inputs and what it returns. Yeah, so that's what it needs. So here, let's get back to deposit one here. Oh, and I almost forgot to mention, but here we did met price convert address in betting game and betting game registry here, and this basically refers to the smart contract address of this price converter later when we deploy the smart contract, because as you can see here, the price converter is going to be defined right when we deploy the smart contract here from the constructor. So but don't worry too much about that. Basically, that address is going to be used to call the price feeds, the price converter smart contract here. So we need to use the interface, as I mentioned. So it's gonna be price converter price feeds equals to, or maybe name it price converter as well, equals to price converter of the price converter address. And in here, we're basically want to calculate the amount that needs to be deposited by the creator or the challenger of the game. So in here, we're gonna define a token amount, which is going to be the price converter dot get derived price of the base address, the quote address, and the decimals will be 18. So that's it. Save. And it has error, I remember, yes, because the output here, as you remember, it's gonna be in 256, which is which is a sign integer, but in this case we want it to be UN 256 because safe transfer from only accepts UN 256 in this case. So to do that, basically just easily UN 256 function, and there you go, and everything's solved. So now we have the token amount. Basically, we can just change this into token amount or the safe transfer from, and also this shall be the token amount for deposit. And there you go. Basically, that's the integration of the price converter Chainlink into the deposit smart contract. So right now, basically, when the creator or the challenger want to deposit an asset, uh, the smart contract is first gonna calculate how much tokens that are going to be deposited, and then uh, of course, before using transfer from, we need some approval before doing the operation. But basically, after calculating, it's gonna access the fund, the ERC20 token fund, from the user wallet to transfer it from their user wallet to the betting game smart contract, which is this smart contract. And then once that's done, it's going to register the deposit token address into token address in case like it's still empty, which is basically the first time the creator deposit the asset. And once that's done, it's basically just gonna emit a deposit event with this with these parameters, so that we know that uh, the the deposit function I mean the creator or the challenger has successfully deposited an ERC20 token into the betting game smart contract. So yeah, that's it. And the other one, so that's for the price converter. I think that's shouldn't be too complicated. And for the next one that we are going to need is going to be the VRF, as I mentioned, which we're going to use in the play function right here to determine randomly who's gonna be the winner. So to do that, let's go back to the documentation so that I can show you guys how to read the documentation as well. So the VRF should be somewhere around here. Oh, my bad. Just below the price feed. So yeah, so similarly to just now, they already provided us with the smart contract code as well. So we can just use it very quickly. But of course, I'll be explaining a bit what are these going to be as well, because it's going to be a bit more complicated than just getting some functions, getting some price feeds from the smart contract. And here, wait for a second for the random number consumer. There you go. So here we have the random number consumer. Basically, this smart contract, this simple implementation of smart contract is gonna be the one that help us to generate a random number on the blockchain, because originally blockchain is programmed to be a deterministic machine, and it cannot really generate any random number, otherwise it broke the deterministic paradigm. That's where Chainlink comes in to help us provide a random function that is verifiable on the blockchain itself. So here, as you can see, the random number consumer is gonna be inheriting the VRF consumer base library provided by Chainlink here. And there's going to be a couple of variables that we need here, such as you can see here, the most important one is basically 1, 2, 3, and 4. Here basically we have the VRF coordinator address. Basically it's a smart contract that gonna be existing in various different networks. So if you're working with VRF, basically you need to deploy in one of the testnet where the VRF coordinator smart contract exists in order to generate the random output. So this one is for Coven. This one is exclusively for Coven, and then the link token is also exclusively for token, and we'll need that to generate the random function, and we'll see more later. And then there's also another variable called key hash here, which we also need. It's gonna all this information basically are exclusively used on uh, uh, one chain. So different chains will have different VRF coordinator address, link token address, and also the key hash. And also the fee is going to be different as well. In general, it's going to be 0.1 link, as I remember in the Rinkaby and Coven. Let us see here the contract address. As you can see, they have the one in Polygon mainnet, Mumbai, BSC testnet, Ethereum mainnet, and Coven Rinkaby. And as you can see, these are the info where you get the laying VRF coordinator, key hash, and fee. And as you can see here, for Coven, it's going to be 0.1 link. Rinkaby is also 0.1 link, but keep in mind that every chain is going to be unique. So like Ethereum mainnet is going to be 2, and then BSC testnet is 0.2 link. Oh wait, this is the mainnet, but you get the point. Basically, all this information need to be matched up when we're deploying the smart contract in different blockchains. So yeah, so basically those information you need to get it from this link here, docs.chainlink/docs/VRF contracts. But once you set it up, you just need to focus on this two function, which is the one is the get random number one, where we'll request the random number, but the random number itself gonna be outputted on a callback function from the VRF consumer base, which we're going to override, as you can see here, and it's gonna be an internal function, so keep that in mind. And here, the name of the method function is going to be called fulfill randomness, and in this case, it's going to output the result on the second input, second parameter, and from there you can set it into the storage variable random result here, which then later we can read it. So the process when we're generating a random number, let me repeat a bit, is that first the user is gonna call the get random number function, method function, and then here it's gonna check whether they have enough link balance within the smart contract or not. Otherwise, if it's not enough, it's gonna throw an error, and then it will return a request randomness, which is gonna be outputting request ID here. So actually in here, as you can see, it's gonna return a byte 32 of request ID, and here we can, if we want, we can just click request ID equals to the request randomness, and it will basically return this value, the request ID, and this value is going to be passed down here. It depends if you want to use the result or not. Usually we'll use it for mappings purposes, as we shall see in our betting game smart contract later. But once that's done, basically it's gonna call the fulfill randomness callback function and output the randomness from the second parameter here, and you can do whatever you want from there. So here, let us compile the smart contract really quickly and then deploy the smart contract. Deploy it. Oops, I might be choosing the wrong one here. It's gonna be the random number consumer, yes. And yep, let's just confirm deploy. Oops, yep. So now it's deployed. Now keep in mind that this is not production grade contracts, because as you can see, all the values of these variables should be variables are integrated into the smart contract. So basically these can only be used in the Coven, but if we want to deploy it into multiple smart contracts, as we shall see later, we should make this into a variable from the constructor themselves. So it is deployed now. So let's try to generate a random number then. So to do that very easily, we just need to get a random number. But as you shall see here, it's gonna throw an error because actually when we deploy the smart contract, we haven't fund the smart contract with any link tokens yet. So to do that, let's just try this, and it will throw an error. It's gonna fail, but just to learn, because we learn from doing mistakes, of course. So it's gonna be pending, and as you can see, the transaction fails as expected. And this is mainly because we don't have any link within this smart contract. And keep in mind, it's not because you don't have link in your user wallet, it's because you don't have link in your smart contract. Because as you can see, if I have a lot of links in my user wallet. So to do that, to resolve this, basically we just need to fund some link into our smart contract. In this case, let me send the address some link tokens. Let me give like 0.5 so that we can have like 5 tries, because each try is gonna take 0.1 link. Next, then confirm. And then after doing so, let's check out covenetherscan.io to check the smart contract, whether they have accepted any ERC20 token yet. It's gonna take a while, so don't worry about it. Okay, so seems like now there are 0.5 link within our random number consumer smart contract. Now we'll be able to get a random number without getting any error at all. So let's get a random number. So right now, the random number is defined up here, but we haven't defined any values here, as you can see from the constructor or anything, and we haven't called the fulfill randomness because we haven't called the get random number. So in this case, it will just input a 0, which is the default value for UN256. So yeah, let's call the get random number, and we shall see that the random result is going to change into a randomly generated number on the smart contract. So confirm, and it's going to take a moment here, even after the transaction result is successful. So just hang on for a sec. So there you go, the transaction is successful. It's quite quick. The random result is going to come a bit later, but just wait for a moment. Okay, guys. So sorry for the wait, and it takes like a full 1, 2, or 3 minutes. But right now, as you can see here, basically we get a generally generated verified random number on our smart contract, and there you go. It's just basically that easy. It's gonna take a while for sure, but yeah, it's gonna be there. Maybe it's gonna be quicker when you're doing it on BSC or Polygon, but the same techniques basically applies. So yeah, in this case, as you can see, the number is quite big though, and we probably want something more manageable, maybe something that can be like like if we want to have like 6 sides of dice, which is just gonna be the output of 1, 2, 3, 4, 5, 6. We probably just want to limit our input to those 6 numbers, but in this case, we have this huge number. So in order to do that, here they also provide us with some code on the VRF best practice here. So to do that, basically we just need to getting a random number with range here, where basically we're just gonna divide it with 50 and get the remainder. This is a modular uh, operation. So basically it's gonna get the remainder from dividing any number on here, and then we're gonna add it with 1. It's optional, but basically the thing we need is the remainder one. So to do that, uh, let's fix our smart contract again, and here random result is going to be divided by 6, for example, for number size of die, but we need to plus 1 here, because if not, any number that is divided by 6 is going to have either 0, 1, 2, 3, or 5, but not 6 itself, because 6 divided by 6 is going to be 0 remainder. So that's where we need to plus the 1. So to do that really quickly, let's just deploy another smart contract. For this one, let's compile it. Compile random number .sol, yes. And then deploy the smart contract again. And wait for a moment, confirm. And then of course we need to send some more link again into the new smart contract. The old one is basically gone unless you define a withdrawal link on the smart contract where you can withdraw your link from the random number consumer smart contract. So here you go. So let's just quickly fund our smart contract again with some links. This time probably I'm just going to fund it with 0.2. Then, oops. Okay, never mind. I think it's 0.2, right? Yeah. So just next and confirm. And there you go. It's going to send my link into this smart contract here. So let's check it out really quickly as well to confirm that the link has arrived into our smart contract. Otherwise, it may revert an error again into ours when we call the get random number function. So yep, seems like it's already deployed just now, as I remember. So let's call the get random number again, and this time the random result should be from the range between 1 till 6. So just get random number and then confirm, and in just a moment we should be able to get a random result within the range of 1 till 6. It's gonna take a while again, so I might cut the video again. So there you go, guys. Here we already get the random result here, and this time it's not 0, it is the value of 1. So yeah, seems like we're successful. We've been transforming the number from a really huge, large number into this time within the range of 1 till 6. And basically every time we call the get random number, it's going to generate a new one for us and redefine the random result within the smart contract. And so yeah, this is all good that we can generate a random number within the smart contract, but how are we going to implement this within our betting game smart contract? So yeah, let's try to implement them into our VS Code here. It's gonna be very similar, and I will just copy some code. So we need to first make the smart contract into a VRF consumer base, and don't forget to import the Chainlink contracts VRF consumer base here. And once that's done, we just need to implement the random generation number within the play method function. So in here, what we need is basically to generate a random number. It's basically going to be the same. So let's just copy this code here. Here and save it. And in here, it's gonna return byte 32 of request ID, which I define here. And so it's gonna return this value. And this value is going to be used within this fulfill randomness function as a callback. So in here, once we get the randomness result, this is where we'll be determining the winner of the of the betting game. So as I remember, we also have the mapping request ID to address registry here, where we're basically going to register a mapping of byte 32, which is going to be the request ID to an address so that we can identify which address is it, the creator or the challenger that is generating this request ID, because we cannot really pass our the msg.sender variable here to this fulfill randomness, because in this case the callback function is going to be called by the smart contract itself. So the msg.sender is not going to be the person that calling the play smart contract. So keep that in mind. So in here, let's register the request ID. Registry of the request ID is going to be the msg.sender. And in this case, in the fulfill randomness, the thing that we will want will be basically to register the result of the randomness into another mapping here, which is the player bet record registry. So this is where the randomness result is going to be stored in the UN256, and the address is going to be either the creator or the challenger address. So let's get down here. So to get the player address, we're just going to address player. This is going to be either the creator or the challenger for sure, because we only give access for the play function to be accessed by only creator and challenger. And this is internal, as you remember, so it can only be called within the smart contract itself. So the address player is going to be fetched from the request ID to registry request ID. And this is how we get the address of the msg.sender. And then from there, we are going to input the player bet record registry, the randomness value, into here. So there you go. And once that's done, basically we want to check whether both players have played the game, and if they did, then we want to determine who the winner of the game will be. So it's going to be if the player bet record registry of the creator is not 0, and the player bet record registry of the challenger is not 0 as well, which means that they already played the game, then we will determine the winner in this way. So if the player record bet record registry of the creator plus the player record registry of the challenger. So basically, the random output of the creator and the random output of the challenger sum it up, and it is divisible by 2. Then we will set the winner as the creator. Otherwise, we will set the winner as the challenger. And once that's done, we want to close the game status here. So basically just redefine the status into betting game status dot close. And there you go. Once that's finished, save, and there you go. We have a full implementation of our betting game smart contracts here. So just that really simple, and we basically have already gone through in developing the smart contract implementation for our betting game DeFi platform. So that's it for the tutorial in this video. I'll see you guys in the next video where we'll be deploying our smart contracts and writing some migration script to deploy the smart contract using Truffle CLI. So I'll see you guys in the next video. If you guys still have any questions regarding the DeFi betting platform we just built or the tutorial itself, make sure to go to this forum at forummoralis.io, and I'll put the forum link down in the description, and here we'll help you with your questions as soon as possible. Also, make sure to like and subscribe to our YouTube channel if you want to see more Web3 tutorials like this. Thank you guys so much for watching, and I'll see you guys soon. Bye bye. Welcome back to the channel, guys, and in this fifth video in the tutorial series where we'll be continue building our DeFi betting platform, we're going to focus on compiling our smart contract, writing some migration scripts, and deploying our smart contract into a testnet network. And in this case, we'll be deploying into Coven. So to do that really quickly, before I go further into the tutorial, before that I need to give you guys a hint here that something that I almost forgot from the previous tutorial, where we need to emit the play event here in the fulfill randomness, where the player address is going to be the first parameter and the randomness is going to be the second parameter of the event itself. But other than that, you guys can edit by yourself, but other than that, sorry, there will be no difference at all. So let's just continue with the tutorial then and deploy our smart contract. So first thing first, we need to compile our contract. So to do that really quickly, you need Truffle CLI, and I assume you already have one. And so just Truffle compile, but in here in package.json, I already have the compile scripts here. So I just need to use yarn compile, and that easy. Truffle will basically compile our smart contracts into the ABI format. And for those who don't know, ABI is basically just like a compiled contract where it will tell us like what kind of functions, definitions, variables that exist within our smart contracts. And there are a lot of compiled ABIs in here, but not to worry, it's because we were importing a bunch of libraries and other smart contracts such as from OpenZeppelin and Chainlink. So here, one of the example that we're going to use is gonna be the betting game one, and as you can remember, the first one is going to be the constructor, and these are the list of the of the parameters that are going to be inputted in the constructor. Of course, it's not just gonna be constructor. There are also events and also all the method functions. Basically, it defines what the smart contract is structured. And this basically, we are going to use this to not only deploy to the test network, but later we will also be using them to interact with the smart contract themselves from our client React app. But it's going to be in the next tutorial. So once we compile the contract, basically here, what we need to do is write a migration script for our smart contracts. It's basically telling Truffle how we are going to deploy our smart contract. So just quickly here, going to the migrations folder, and as you can see here, we only have the initial migration here. This is basically how the basic migrations file gonna look like. In this case, it's deploying the migrations smart contract, which is the contract that handles all the migrations. So similarly, let's make the migration script for the smart contracts that we want to deploy. And in our case, we want to deploy 3 smart contracts. The first one is going to be the betting game registry. The second one is going to be the price converter one, where we'll be able to convert the prices from Ethereum to an ERC20 tokens, as we showed in the previous tutorials. And the third one is going to be an ERC20 token basics here, which is basically an implementation for our bet ERC20 token. And this is what I have showed you in Remix. I just copy it into our local file so that we can deploy it by ourselves. And we don't need to deploy betting game into the testnet, because the reason is that the betting game registry is going to be our contract factory, and it's going to be the one that create a new deployment of the betting game on the blockchain itself. So the only thing we need to deploy is the betting game registry, and the betting game smart contracts are going to be deployed by the betting game registry. So in here, basically, we need 3 files because we are going to deploy 3 smart contracts. Of course, we can include them in one giant file, but we're not going to do that. So in this case, first let's deploy the ERC20 basic, the JS. And in this case, let's just copy the one we have on the migrations. And important thing to mention is that don't remove the migrations related stuff, because it come out of the Truffle project, and it's very important to keep track of like when deploying the smart contract. Basically, Truffle handles all those migrations out of the box, so don't remove anything related to that. So here we're just gonna do an ERC20 basic, and this is going to artifacts.require ERC20 basic. It's going to import the smart contract, and ERC20 basic here is not referring to the ERC20 basic.sol, but rather it refers to the name of the ERC20 basic contract right here. So you can have different name for this one, but as long as this one stays ERC20 basic, you will be importing it just fine. So once that's done, we just basically need to module.exports the function. And here we're going to use deployer to deploy the ERC20 basic. And once that's done, then we'll be able to deploy our ERC20 token smart contract, the bet smart contract. So Oh, I almost forgot other thing, that we need to include other parameters because the constructor need some parameters here, such as string type for name and string type for symbol. And in this case, we only need to include them in the next parameter for argument. So just here, it's going to be betting game token for the name, and the symbol is going to be BET. And once that's done, we'll be able to deploy our ERC20 smart contracts a bit later. But now we're going to finish the other migrations script for the betting game and also the price converter. So first, let's do the price converter one. Let's just copy this and rename it deploy price converter.js. So in this case, as you can see, I number it as 1 to 3. The reason is that because when we're migrating, Truffle will check these numbers and it will run the migration script in order. Basically, it's going to run the first one, the second, and the third one, and so forth. And for this one, we're going to use the price converter. And here we're going to import the price converter smart contract. And here similarly, just change it to price converter. And as I remember, the price converter one does not have any constructor, which means we don't need to include any parameters for that. So just that simple, and we already did 2 migration script for our smart contract. And the next one is gonna be the betting game one, and this time we will be needing the ERC20 token and the price convert contract address, and let me show it for you in a bit here. And also that's the reason why I'm putting this as the last contract to be deployed. So there you go. So once that's done, let's import the other contracts, also the price converter, require price converter, and then here const betting game registry artifacts dot require game registry. And in this case, the other thing that we'll be needing are the Chainlink VRF information, which I mentioned before. We need the link token address, VRF coordinator address, key hash, and fee, and those are going to be unique to different networks of the blockchain. So here I already have the list in JSON format, so you guys don't need to do to copy all those stuff from the websites, because I already include them here. And here, in order to detect which network we are going to use, it's going to be network as a second parameter, and then we can import the Chainlink VRF file. Oops. And use require this time because we're not importing the smart contracts, and we're going to import list chainlink vrf.json. And from there, the Chainlink VRF will get basically the value of this whole JSON object in here. So, but we just want this link token address, VRF coordinator address, key hash, and fee based on the chain. So to do that, we can basically just const chainlink VRF obj, and then just take the one based on the network name, which is gonna be this one. So So in this case, if it's Coven, then it's just going to take the Coven one here, and it's going to have all the link token address, VRF coordinator address, key hash, and fee. So once that's done, we can just we also need to get the ERC20 token and the price converter address, and to do that we need to first get the ERC20 basic instance by doing await ERC20 basic dot deployed, and in this way we'll be able to get the address by using ERC20 basic inst dot address later. And in here we should make it async because we're going to use an await here. And similarly, we'll do the same for the price converter instance. So just like that, very easily, we just get we'll be able to get the ERC20 token address and also the price converter address. And to before that, let's go back to the here. Let's change it really quickly to betting game registry because we're going to deploy the betting game registry smart contract. And let's see what constructor do we need to include in our deployment. So as you can see here in the constructor, there are a couple of stuff we need, such as the native token address, which is going to be the ERC20 token address, and then the VRF coordinator address. The price converter address first, which are going to be the price converter instance address here, and then these are going to be from the Chainlink object, and we already have that. So yeah, let's just do that really quickly then. So the first one is going to be the ERC20 basic instance dot address, and then then the second one is going to be price convert instance dot address. Let's save it here so that it's easier to see. And then the third one, it's going to be from the Chainlink VRF object, and it is the VRF coordinator address, and then Chainlink VRF object of link token address. And then the key hash similarly, and also the fee. Just to look it really quickly here, let's go to the list. And then in here, it's gonna be link token address, VRF coordinator address, and the key hash and fee, and those looks all just fine. So basically, once that's done, we just finished writing our migration script for our smart contract, and using this, we'll be able to migrate our smart contract, deploy our smart contract into testnet or even mainnet if you would like to do that too. And so let's just do that really quickly here. Let's clear the terminal. And then here in the package.json, I already have the script as well for migrate. So we just need to do that. Of course, before migrating, you need to make sure that your wallet has some fun as well. If you forgot, you need to go and truffle console, which is I'm going to use console, and I'm going to use the network Coven here. And just a moment, it is going to connect me to the Coven network from the console. And in this case, I can check. I'm going to put this into a variable. Get accounts. And then I can just web3.eat.get balance of accounts 0. And there you go, it's not 0. So this will be sufficient for me to migrate the smart contracts. But if you have it 0, make sure to go to any faucet to get some testnet tokens to deploy the smart contract, because you're going to pay some gas fees for that. So let me exit the console, and then we can migrate the smart contract by using yarn migrate network. Basically, this network is going to be referring to the one you have in truffle config. In here, truffle config, and let me just, and as you can see here, we have a bunch of network configuration, like, and here is the name, like Coven, Rankaby, and other stuff, mainnet, Binance testnets, and Binance mainnet. So just refer this as to the name of the network you need to input here on the CLI. And of course, this is going to be the name that is going to appear here on the network as well, network parameter. So yeah, let's just continue migrating now. So this is going to take a few minutes, so I'm gonna skip when I finish migrating my smart contracts. And yeah, so just wait for a moment, and we'll come back once we finish deploying. Okay, guys. So my migration is finished now, and everything is successful. So it takes like a couple of minutes, but it's okay. And if you guys have some trouble like failing to migrate, that's okay. Usually it might be network issue or those kind of stuff, but not to worry. You can just run again the yarn migrate network coven, and it usually, because it already saved the migrations, truffle already handle all the migration. Usually you will just continue where you were left off, so not to worry about that. So in here, as you can see, I already deployed my smart contract, and as you can see, it takes an order. The first one is deploying the migrations one, and then the second one is the ERC20 basic, and then the price converter, and the last one is the betting game registry. And yeah, so once that's done, basically these smart contracts are going to we can basically check them directly in Etherscan. So let me just go really quickly. Etherscan Coven. And the contract should be there, and we just deployed like, yeah, just recently, like 2 minutes ago, so that seems right. And here, as you can see, like it's gonna like have all the information about my smart contracts. Usually, like, it doesn't verify my contracts like this automatically. Usually you will need to verify your contract manually, but seems like somehow it verified mine like once the migration is done. But in the case if you your smart contract was not verified, then you can do that. Of course, this is optional, but usually the thing is that if you didn't verify your smart contract, you won't be able to check your code here, like what is being deployed, or maybe even get the ABI below here, or maybe even like, yeah, you cannot read the contract or write the contract because you haven't verified yet. So yeah, basically if you want to access those, you need to verify your contract. And to do that really quickly, we also already include travel plugin verify in our package.json as a plugin. And there, the thing you need is your Etherscan API key, Polygon scan API key, BSC scan API key. Of course, you don't need everything if you just going to deploy on an Ethereum network or even testnet network, then you just need to have the Etherscan. But in case you need to deploy into Polygon and then BSC, Phantom, and this one's no traces Avalanche, then you will need to get the API keys by creating an account there. And I'm not going to show that. And of course, you need to put this into the environment variables, which is the .env file right here. And once that's done, basically, let's verify our smart contract. To do that, we also already have one, have the scripts in the package.json. Let me look at it really quickly. So here, truffle run verify. We're going to verify 3 contracts here because we deployed 3. So betting game registry, ERC20 basic, and the price converter smart contract. And the other thing we need to verify is the network where we deployed our smart contract that we want to verify. So in this case, we will verify on Coven. So yarn verify Coven, and it's going to take a few minutes to deploy to verify our smart contract. Somehow in this case, it doesn't really detect my betting game registry one somehow, but usually it will do. If not, then I guess the easiest way to resolve it is to migrate again your smart contract. Otherwise, if it's successfully verified, that it's gonna give you the link to the smart contract here, which basically the one that we can access. So right here is going to be my ERC20 smart contracts, and there you go. Basically, that's all we need for deploying our smart contract. So once that's done, basically, we just need to copy the address of our contracts here. So as you can see, we can copy our contract address and copy them to our main folder. So let me go to the main folder because this is the truffle project within the repo. So let me go above one level and open VS Code from there. And there you go. And in here, basically, we'll be putting our smart contract addresses into each of these individual contracts. This is basically deployed contracts.json, as the name of the file say. This basically store all the addresses of the deployed contracts in various networks. And in here, I have 3 because I deployed in Coven, BSC testnet, and Polygon Mumbai. But if you just want to test it out in Coven right now, you can put the corresponding address of the ERC20 basic betting game registry and the price converter address that we just deployed into each of these smart contracts. So then we'll be using this later in our React client app, which we are going to explore here next one in the next video. So the other thing that I want to point out is basically that we don't actually want our build folder, the ABI, to be under here because we want it in our React project. So that's why in here, if you comment this out, then you'll be able to redefine your contracts build directory into your React project instead of under the Truffle project. And let me show you really quickly. So if I delete this and I compile my contracts again, this time it will appear somewhere somewhere in the SRC under the SRC React project. So in here, if you can see, ls src, yes, I think that's good. Yeah, so this will basically list all the files and folders in my src file that I mentioned here. This is the React project. But if I do a truffle compile again, uh, and here keep in mind there's no contracts folder right now, but there's soon gonna be. So first I need to go inside truffle again, and then yarn compile, and this time the build contracts, the compiled ABI is going to appear within our React project. So that way we'll be able to use our ABI directly uh, when integrating our smart contracts with our client dApps. So let's go back and list ls, this time dot src. There you go. And this time, as you can see, we will be able to get the contracts folder, and this is going to be the ABI. If you don't believe me, let us go even further. And there you go. This is all the JSON that we just saw before, and this is where the ABI is gonna live. And this basically will give us convenience when importing and getting the ABI to interact with the smart contract later in the client app. So yeah, so that's all for deploying our smart contract. Hopefully you learn a lot from this video, and hope to see you in the next video. If you guys still have any questions regarding the DeFi betting platform we just built or the tutorial itself, make sure to go to this forum at forummoralis.io, and I'll put the forum link down in the description, and here we'll help you with your questions as soon as possible. Also, make sure to like and subscribe to our YouTube channel if you want to see more Web3 tutorials like this. Thank you guys so much for watching, and I'll see you guys soon. Bye bye. Welcome back to the channel, guys, and in this sixth video in the tutorial series, we're going to continue to build our DeFi betting platform dApp using Moralis and Chainlink. And if you've been this far, that means like we just finished our smart contract development, and now we're going to focus on developing and connecting our smart contract to our client React app that we have in here. And if you guys are still in the travel project, make sure to go one level so that you can be on the Moralis betting protocol folder, or basically the root folder of the repository. And as you can see here, since we finished the travel project, that means we're not going to explore any files or make any changes within the travel project anymore. And now we're just going to be focusing our energy all into the src folder for the rest of the tutorial series. And basically these are going to be everything that we are going to use in our client dApp. And as you can see here, this is based on the Ethereum Boilerplate. They provide a bunch of functionality. The original one, most of them have like the components. As you can see here, I have added additional components, but they have address, chains, and block keys, ERC20 balance, native balance. Those are originally from the Ethereum Boilerplate, which we'll use out of the box. And then they also provided some hooks, which is very nice in order to get some data or even interact with the smart contracts using MetaMask, and a bunch of others like use IPFS, DEX if you want to build your own DEX within your dApp, and many other bunch of Web3 functionality. And these are all basically connected to the Web3 API that is provided by Moralis. And so there are other functions as well here, which are nice to have, such as the helpers. And we have basically here like formatters, validators. Formatters is basically where we can format some data such as numbers and text, and token value tags. And then The validator is basically something that I made to determine whether uh, an address is a zero address or not. This is just what I made by myself. And the other one is the network configs, where basically it's already provided out of the box about all the information about each network, such as this one is going to be mainnet, and then this one Robson, Coven. So we don't need to fetch all this information. We can just import it in our dApp, and just that easy. We can use it to display the information in our dApp itself. So yeah, very, very helpful. Definitely check out the Ethereum Boilerplate if you're going to build your next dApp. And so in this video, uh, we're going to focus on developing our dApp, mainly to integrate our dApp with the use Web3 contract in the hooks here. As you can see, we have use Web3 contract hook. Basically, this is something that we'll be using a lot throughout this tutorial video to interact with the smart contract, either to make a call request, which is basically to uh, get some data from the blockchain, or either to interact with the smart contract, such as to make some kind of transaction with MetaMask. So yeah, but you don't need to differentiate. If you're using web3.js originally, you need to differentiate whether it's a call or a send. But in this case, we don't need it. We just need this function, and they have provided like the data. The data is going to be the contract response here, the output, and then the run contract function to run the function itself. The error is running, is loading. Everything is already provided out of the box, and you don't need to configure it by yourself. So here, let us see for a moment in the search here. As you can see, I have provided some comments here. What do we need to implement throughout the rest of the tutorial series? But basically here, as you can see, we have use Moralis Web3 API call. Most of them are gonna be use Web3 contract, and as you can see, and there use Moralis Web3 API call is basically to make a Web3 API call to get some data from the blockchain themselves. And then there's also use Moralis query below, which is basically uh, something, a hook that we will use uh, in the next video, because we basically need to build new database, uh, and it is basically used to fetch some data from the database themselves. But we'll explore them a bit later. We're going to focus in this video will be the use Web3 contract and also the use Moralis Web3 API call. So here, as you guys can see, maybe let's run the dApp really quickly as well, so I can explain the structure of the contract. I mean the dApp itself with the components, because there are a bunch of components in here that I built, so we can relate to that. And here basically, like as you guys can see, oops, I need to authenticate first, basically to log in. And once that's done, then the me menu is gonna appear, where I'll be able to view the bets that I created. But right now everything is empty because like we haven't implemented any functionality in the dApp itself. So in here, basically, the thing we want to achieve is being able to create a game, as I shown you before, where we'll be able to burn a bet and then deposit ERC20 token, and also play the game and interact with the Chainlink oracles. So here, if you guys remember. Then in here, uh, like as you guys can see, we have the burn token, the deposit asset, and the play game one for our dApp. Basically, those all exist within the game model here, components, and then game model. As you can see, it's gonna be shown in the game model components right here, and it's basically based on the index of the progress themselves. So if we progress further into the index here and we check the steps, you guys can see there are some steps here that we displayed before, and the steps index are going to be corresponding to the component that we are going to render here. So if the index is 0, it's gonna be, we're going to render the burn token, which is basically right here. It's going to be the burn token component, and then the next one is going to be the deposit asset and the play game one. And the last one is the show result, which doesn't have any smart contract interaction, so we can just ignore that. And we're going to be focusing ourselves mainly on these three components right here. So in order to warm up, basically we also have another file where we need to implement the use Web3 contract first before we go into the game model, because as you can see, it's a multi-step process and involve a lot of smart contract interactions. So let's start with a really simple one here, where we'll be able to mint a token from our testnet faucet here. As you can see here, I have a faucet page, so I cannot actually close this one, and I'll just make this faucet and then get up to 100. Basically, this is going to be the faucet page where we'll be able to request, will enable the user to request testnet bet token, ERC20 token that we just created in the smart contract to the user themselves, so that they can mint some for themselves. So in this case, as you can see, if it's 0, it's going to be disabled, but if it's 1 or more than 0, basically, we'll be able to request some testnet from there. But of course, right now, if we click it, nothing will happen, and that's where we'll be implementing the use Web3 contract. So let's do some basic implementation, do a bit of warm up in this part. So so to do that, first basically we need to import some use Web3 contract here, and in this case we will be use Web3 contract and then contract response. Actually, I sort of forgot what the output is going to be, so I'm going to open this on another one here. So use Web3 contract, and then I'll close this one. Faucet is this one. Yep, great. So this is gonna be the output of the use Web3 contract. So we have contract response is running, is loading, and also the run contract function. So we're just gonna use those. We are not gonna use the error in this one, but for a real use case, definitely it's recommended to use the error functionality to do some error handling, because you don't want some nasty error to appear on your user's UI. So there you go. And the parameters is going to be, first is going to be an ABI, and then it's going to be ABI function name, and then function name and then the contract address. Sorry. And then the params. So yeah, that's all we're going to need. And here let's get the is loading and is running variables. So in this case, what we need will be the ABI. And to do that, since we already compiled our ABI here, and I already have the code actually, so we can just comment this out and comment this out as well. So basically, these is going to fetch the ABI from the ERC20 basic.json that we compiled in here. As you can see, the contracts one, ERC20 basic. This is based on the ERC20 basic smart contract that we developed before and we compiled here if you follow the previous tutorial. So once that's done, we're not going to use the whole file. We're just gonna extract the ABI part here. Let me show you because that's the most important thing. As you can see, the ABI part, because if you try to fetch the whole ABI, it's going to be extremely huge and not necessary. We're just going to fetch this little part here, the ABI field. And once we fetch it, we destructure it. Basically, what we need is to input this into the ABI right here. And since it has the same name as the parameter fields here, we don't need to input anything. So just ABI right here. And the function name is going to be minting, I suppose. Let me check really quickly. ERC20 basic here. So mint, yeah, it's gonna be minting function. Maybe let's move it here so that it'll be easier for us. So minting with parameters of address to and amount in UN256. So basically that's how we read the ABI right here. We just need to read some specific part of the ABI like the function name and then the parameters, and that's what we're gonna use here. So the function name is going to be mint as it is there. And then the contract address is going to be something we have deployed before, and we inputted those in the deployed contracts. So we can just use them directly here. So we can do that here, deployed contracts. And then chain, yeah, I think like I need to put the chain ID, but the chain ID needs to come from here, from the use Moralis dApp. It's basically a global context where they provide the wallet address and chain ID, and it's also uh, provided directly by the Ethereum Boilerplate, which is very nice and makes everything very simple, makes everything easily resolvable in a few lines of code. And as you can see here, we already have the deployed contracts chain ID. If you want to see, we can look into what it looks like here. So it'll be much clearer again. So here, let me put it here. So as you can see, the structure of the deployed contracts here are going to be JSON, and we need to basically index them based on the chain ID themselves first. So this is going to be Coven, BSC Testnet, and Polygon Mumbai. But we want to be a bit more flexible here, so we are just going to use the chain ID. So using the use Moralis dApp hook, basically it's going to detect the chain ID automatically, and whether if we change the to a different chain, it will detect it as well. And in here, of course, they will look into the wallet address of the user as well automatically without you needing to resolve anything. So just like that, then we basically need to choose the ERC20 basic because we want to use the ERC20 basic bet smart contract token to interact with. So here we're just gonna dot ERC20 basic, and in the params, let's input the two parameters, and it's going to be the wallet address of the user that's interacting with. In this case, it's my wallet address, and also the amount of the bat value that is going to be minted. And in this case, we want it like if we want it to be one, we do need to provide the amount value in way such as like because the ERC20 basic is have 18 decimals, that means we need to provide the amount like one with 18 zeros. But that's quite a hassle if you ask me. Luckily, Moralis already provided a units function to handle that kind of thing. So here we just use the Moralis object from use Moralis, and there we'll be able to translate the amount from 1 till to the amount in way. So it's gonna be moralis.units.token. And in here, as you can see, we just need to provide the value as the first parameter in string or number, and decimal as the second parameter in numbers. So the decimal is going to be 18. There's no question to that. And the value, it's going to be depend on the React state right here, the bad value. It's going to be connected directly to what we type here in the input number. As you can see, the value is connected to the bad value themselves. So here we just need to input the bad value, and basically this way it will translate the units from 1 to 10 to the power of 18, basically depending on the decimals, but in here we're gonna use 18. So just as simple as that, and we are already quite done with the minting function. And the next one, basically we need to run the contract function to fetch the data, because it's not gonna fetch manually. So to do that, let us see right here. Basically, once the user click this, so click the button, it's going to call the contract function for us. So here, what's the name of the function again? Run contract function, and just as simple as that, and we are done basically. And then of course we want to disable the button when we're requesting or minting the token from the smart contract. So basically here we're going to disable it when it is loading and it is running here. So once that's done, that's all good. And do we need the contract response in here? I don't think so in this case, but in the other implementation we probably need it. So in this case, just need this, and it should be all good, and we should be able to mint our token successfully in this case. So let's try it out. So let's, oops, seems like something wrong. Somehow it should be disabling the button, but it's not. Oh, my bad. It should not be N right here, because it's going to make it false. It should be OR. So there you go. Once that's done, oh, it should disable the button. Yes, that looks great. So now suppose I want to mint one BET token, and in order to do that, just click this, and in a moment, boom, MetaMask will prompt us to sign transaction, and we can just confirm, and it will mint the token into our wallet. Because remember, I already added my BET token right here, so yep, so this is exactly the same one that I have, the BET token that we're going to mint. So yeah, there you go. It just minted one new BET token into my wallet address, and just that easy. So yeah, basically this uh, hooks that is provided by the Ethereum Boilerplate by Moralis themselves, they made our lives much, much easier to interact with our smart contract. So now that we already know how to basically interact with the smart contract, let's do something more advanced, like implementing the functionality that I just showed before for the game contracts. So here, let us go to the bets here, and we are going to go back here in the create game, and here let us interact with the burn bet one. So here we're going to go to burn tokens, and as you can see here, there are a bunch of information right up in here. So what we need basically in here is just like define the use Web3 contract functionality to interact with the smart contract themselves. And you can see here there, I already put some comments to make it easy. And there are going to be three, which our first one is to approve, because we are going to burn some tokens, and that requires approval, as we explore in the ERC20 token tutorial. And then the create game for the creator, and also the challenge one for the challenger. So to do that, basically here, let us do some do basic implementation for this one first for the approval. So similarly, we need the use Web3 contract. Seems like I didn't comment that out, so we can just use it directly. Oh, but we might need this one for the use Moralis, and the use Moralis dApp, as you guys remember, and the ERC20 basic ABI, because we are going to interact with the ERC20 BET token to do the approval, and then deployed contracts. And do we need this database.json? Maybe not now, because we haven't interacted with the database. So yeah, the only thing we need is also the chain ID, Moralis, and the ERC20 basic right here. And once that's done, let's just really quickly do similar stuff. So const run contract function. So here we'll use Web3 contract. And similarly, we have the ABI, which in this case is going to be the ERC20 basic ABI. The function name is going to be approve. By the way, I already write it here in a comment. I almost forgot about that. But yeah, and then the contract address is going to be the ERC20 basic smart contract. So it's going to be deployed contracts chain ID dot ERC20 basic. Yes. And then the params is going to be spender, and also the amount. And in this case, we wanted, like, if its creator is true, then it's going to use to approve the spender as the betting game registry. Otherwise, it's going to be the betting game address themselves. So in this case, uh let's kind of ignore that for a moment and just use the oops the betting game registry for the creator. So deploy contracts chain ID, then dot betting game registry game registry, and there you go. The reason why I want to skip this is because the betting game is going to be the betting game address that is newly created is going to be fetched directly from the database, and we haven't interacted with the database for now, so we'll add that a bit later on. So the amount is going to be using Moralis units, of course, dot token, and then the decimal is going to be 18. So in here, let us see the amount. Oh yeah, the amount is going to be depending on the number of sites that is chosen by the user themselves. Do we have the sites? I remember we should be able having the sites. So choose the number of sites, and the value is going to be stored in the sites here. So there should be a React state of sites. Let me see for a moment. Oh, you see, so it's not a React state, it's passed down from the game model index. So we can just use that, yes. So it's the number of approval basically, as if you remember from the smart contract, it's going to be 0.01 times the number of sites. So then the bigger the number of sites is, the more bet token that is the user going to burn to create or challenge the betting game that is created. So once that's done, this is going to be run contract function, and it's loading. And also is running. And since we're going to use multiple use Web3 contract, we better rename this as another one. So run approve, and this is going to be is approve loading, and then this is going to be is approve running. So save that really quickly. And once we have that, basically we can go down right here and also disable the button. Yep, we need to include the disable button right here. So apparently I already include the is challenge here, but no worries, because we can just skip that because it's going to be very similar to what we have from the creating game. So in this case, let's is approve loading and is approve running, because we want to disable the button when the one of these are correct, either the approve is loading or running, or the challenge is loading or the challenge is running. So here, then we just need to include them in the dependency of the use memo, so that they will automatically update when the value changes. So once that's done, it's all good, and we'll be able to approve the number of sites when they click the button. So in order to do that, we're gonna run the approve here. So just run approve, and this is basically the button for both the approve and the burning token. As you can see here, it depends on whether uh, uh, the token has been approved yet or not. But yeah, basically it uses the same button right here, the same button component. Let me close this one. And basically after we run the approve, when it's run successfully, we wanna set the is approved set the is approved state to be successful, so that in this case the next time then the next time the person is going to click the button after approval, it's going to be changed to burn. And also in this case they will be either creating a game or challenging the game itself instead of running the approval again right here. So in here basically we want it to be true. So once that's done, the UI will change, as I mentioned. And in this case, as I remember, yes, the input shall be disabled as well once the is approved is going to be true. So yeah, once that's done, it seems all good. So basically, yeah, we can just try to run it right now. Oops, seems like something is not right. Oops, okay. So seems apparently here, seems I missed one thing. Oh, it should be set is approved. There you go. So everything's all good now, and we can go back to our application. And in this time, if we try to approve uh the the token, it'll be successful. And next time we should be able not to get any error when we try to burn the token. So let's just try to do that really quickly here. Oops. Yep. Seems like everything is working fine for the approval. So just confirm. And in a few moments, this button will change to burn, and this one, the input fields will be disabled, and we will not be able to change it anymore in the future. So yeah, once that's done, great. Now we'll be able to burn the token to create the game or challenge the game. In this case, we're just going to focus on create the game. Uh, so in here, similarly, we are just going to do the same thing. So contract respond, run contract function, then is loading, is running, use Web3 contract, and then the ABI is going to be the betting game ABI, the betting game registry ABI, because we want to approve the game registry. As you remember, to create the create game is in the betting game registry smart contract. So the other one is function name. It's going to be create game, and then the contract address is going to be the deployed contracts chain ID, very similarly, and then the betting game registry. And then the params is going to be, let me see really quickly here, is just the number of sites, so we just use that here, underscore sites, and it's basically going to be the number of sites that have been chosen. So once that's done, we need the ABI right here, the betting game registry ABI. So let's uncomment this, and also uncomment this one, the betting game registry ABI, so that we can use it in the betting game. And here we'll add the betting game registry ABI, and there you go. Just a few lines of code and we're done. And in here let's do like run create game, and is create game loading, and then this one is create game running. So in this case, we'll just be adding this as well into disable button, create game loading, and is create game running, is create game loading, and is create game running. So once that's done, the only thing we need to have is to run the create game right here. So basically, if it's the creator, we want to create game. Otherwise, if it's a challenger, we want to run the challenge uh, smart contract right here. So yeah, just very easily like do that as well. Run create game. And then once it's on success, we want to also set it to set is burn to true, basically to indicate whether the burn is successful or not. And then here in this case, here I already defined a use effect where if the is burn is true and it's not creator, so it's gonna handle next. Oops. So I guess I have another one right here for the use effect for the is creator one, but seems like we cannot use all the functionality because this will depend on the Moralis database. So let's just uncommon some of this. I'm gonna just use this two one. If it is burn and it's creator, then it is going to handle next, which basically gonna forward us to the next step. And these are going to be something we need to concern later when we're handling the database. So not to worry about it right now. So betting game data, betting game. We might wanna just remove this from here at the moment. Maybe include this creator right here will be more appropriate. Yes. Save. And there you go. Dependency is not. So there are some. Oops, I see. So I shouldn't comment this. Basically, it's something for the use effect array dependencies, and then let's check like line 90. So this one is create game loading. Oops, my bad. It shouldn't be comma. It should be or. So there you go. Seems like all good. So now when we go back to our dApp and run the burning, we should be successful. Seems like it reset all the React state, so we need to approve it again, I guess. Just really quickly and wait for a moment, then we should be able to burn it this time. So we are back here. The approvals just finished. It takes quite longer than the one before, so let's burn it right now. And this one should be successful. Yes, no error at all, and that's because we already approved the token burning using our wallet address. So now the burning should go as it is, and we'll be able to create a betting game instant smart contract using our betting game registry smart contract. And once that's done, it's gonna create our game, and in here, boom, we're in the next step of the creating game model. And in this case, let us check back to Etherscan. This is the betting game registry smart contract that I already have that we just interacted with. And as we can see here, we just do the create game 20 seconds ago, so it seems correct. And as you guys remember, when we create a game, we also emit the create game event here, so we will be able to see the create game uh, event right here. And this is the newest one 20 seconds ago, and as you can see, there are some parameters that we'll need, which is going to be the betting game address. So this one here, the last one, is going to be the betting game address, and we'll be needing this to deposit our smart contract some ERC20 token after this. So that's why we need the address in this case. So just click address here and click this one, click the address, and boom, this is the newly created betting game smart contract that we just did just now by burning our tokens. Of course, our token will, the bet token will reduce automatically. So in here, let's copy the address of the betting game that we want to interact with, and we need to be a bit quick here because there's actually an expiry time, if you remember, gonna be 30 minutes, but should be more than sufficient for us to implement. So here we'll be using the use Web3 contract hook again. It's gonna be very easy, just a few lines of code. So let's just do it really quickly as well, guys. So here we wanna, so we wanna do is, yes, we will need another approval to deposit the ERC20 contract. But this time it's not gonna be the bet ERC20 contract. It's going to be either Uniswap, Chainlink, or DAI. And yeah, just do that. So first we need approval and deployed contracts. No, we don't need that at the moment. So let's just implement this one then. The use Web3 contract. So approval. So use Web3 contract. Run contract function. And then is loading, is running. And we're going to change this to run approve as well. Then is approved loading, is approved running. And to make it easier, let me format it a bit. So let me enter everything below here so we can easily see everything. There you go. And the use Web3 contract is going to use an ABI, the ERC20 ABI. Hang on a sec. Did we uncommon it right below here? Not yet. So let's use that. And what else do we need? I think, yeah, we definitely need the wallet address. Uh, nope. My bad. We don't need that. What we need is the betting game smart contract address that we just copied just now. So here is the ERC20 ABI, and the function name going to be approve. Then the contract address is going to be this one. We shouldn't be hard coding it, but since we'll be handling it later in the next video when we'll be using some database. So right now we're just gonna hard code it at the moment. So params is going to be spender. Oops, my bad. The contract address should be the ERC20 token. So this time what we need is the the contracts from the JSON. So let's go up really quickly here. Chainlink price feed ERC. Oh yeah, here ERC20 token address.json, where I have inputted some information about the token that is going to be approved. So in this case, it's gonna have the same structure. So we need to have the chain ID, and then the next one is going to be the deposit asset, which in here the value is actually going to be uni, die, or link, but it's going to be handled by the state themselves. So we just need to have it right here, deposit asset, and then the spender. Now this is going to be the betting game smart contract. So the amount this time, it's going to be what we have from the price converter, because I'm as I mentioned, or let me demonstrate it again. Let's go back to the app then. Oops, that if we choose an asset right here, as you can see, oops, seems like I haven't implemented the calculation yet, but basically it will calculate how much asset do we need to deposit. As you remember, from Ethereum to the asset that we want to deposit, in this case like Chainlink or Uniswap or DAI. So in order to do that, we need to use the price converter smart contract. So here I already have it in here as well for the get derived price, which are implemented in the price converter smart contract. So we'll do that at the same time. It might get confusing, so let me explain it a bit later as well. But basically, we need to get the price from converting from E to the deposited asset. In this case, like from E to Chainlink token, and then the result from the from this conversion will be used in the amount for the for the parameters amount here for the approval. So yep, to do that just quickly here, we're gonna use the same one. So run contract function. This time it's gonna be run get price feeds, and then is loading is going to be is get price feeds loading, is running is going to be is get price feeds running, and then use Web3 contract is going to be here we need the ABI as well, which is going to be the price converter ABI, and then the function name is going to be the get derived price, and then the contract address is going to be the deployed smart contracts. Deployed contracts, I guess I haven't uncommented above here, so yes, there you go. So once that's done, we can use it and import it from chain ID. And also this time it should be dot price converter, and then the params is going to be underscore base underscore base, which is also from a JSON. Let me explain it a bit after this. And then the decimals is going to be 18. So here, if we, oops. So if here we're looking into the Chainlink price feeds, this is basically where we'll be able to get the list for our Chainlink aggregator interface that we used before to get the price feed. So you guys don't need it. Don't need to hassle and copy paste from the website. So here we already have it, and I have most of the stuff in different blockchains, and so we can just copy them. It has a very similar structure. Oops, happened. And there you go. So we are going to use the one in Coven, and it's gonna be, as you can see, there's native USD, Link USD, Uni USD, and Dai USD. Native basically it's from Ether to USD, and Link USD is linked to USD, and etc. And in this case, we want it from the as you remember, from, let me write a bit of comment here, from supposedly like 1 Ethereum to how many uh Link, Dai, or Uni. So in this case, as you can see, the price that is provided by Chainlink is gonna be in ETH USD or Link USD, and in order to get the price from ETH to Link, basically we just need to divide it. So ETH USD, which is going to be divided by Link USD, and this is going to be, the first one is going to be the base, and the second one is going to be the quote. So here, if we go back, let's close the sidebar here. There you go. So if we do that, let me, so we can just use the Chainlink price feeds and then chain ID, and then the first one is going to be from native to USD. So this is going to be dot native. Let me just use this optional chaining so that for safety, and then dot USD. So that's the first one, and the quote one will be the deposit asset to USD. So Chainlink price feeds. If you guys still confused, maybe you guys can go back to uh, the video where we discussed the Chainlink one, because I discussed there in details, even going through the docs of the Chainlink themselves. But yeah, that's gonna be the basics. And here we want it from the deposit asset to USD one. So there you go. Once that's done, we can run the price feeds. Now we need to run it kind of manually, and in here, basically in the use effect, when the deposit asset changes, we would like to run the price converter right here. Yep. Oh, the name is run price converter. Did I name it that? If not, we can just change it, but it doesn't really matter. So yep, run price converter. Then maybe I'll change this into run price converter as well. And of course, let's include them into the disable button here, uh, along with the is approval one. So is let's see, get price converter loading, and then or is get price converter running, is approved running. Oops. Seems like some, oops, my bad. Should be something like this. So I can just delete this part. And then the last one is going to be is approved loading. And we're going to include them in the dependencies. Get price loading is get price running, is approved loading, and is approved running. So there you go. This is going to be for the disable button. And once that's done, as you can see here in the use effect, once the deposit asset changes, because it's in a dependency, it will run the price converter and we'll be able to get the amount right here. So this time we can use the contract response, and this is going to be deposit amount. And this will be the parameters that we're going to use right in here. So deposit amount, save it. Oops, run price converter not found. I might change something. And did I miss something right here? Memo missing dependency get price converter. Oops, loading. And also seems like there's a bit of error. Might be run get price converter. Oops, I see. So this one should be run get price converter. So once that's safe, everything should be good. And let's hook the run approve function into our buttons below. So run approve. So by the way, let's close everything in here because we don't need it at the moment. So run approve is going to be right here. So run approve just like that. And let me see for a moment above what state we have. Do we have any state to determine whether the approval is successful or not? So there is approved. So let's just go back right here on success and type and set the is approved as true. And once that's done with, we should save it. I guess I need to define the set is approved here above, which I haven't. So set is approved and save. Then there you go. Seems like everything's working fine. So let's just try to test it out right here. So now let's choose the ERC20 token we want to deposit and approve it. And there you go. Boom. Seems like it's successful. This time it should deposit the amount of the ERC20 token that we would like to have. So in this case, another thing that we want is that even though we can get the price conversion from the Chainlink price convert smart contract that we built before, we also might want to display the price, but in a much quicker manner because blockchain is quite slow. So the fastest way to do that is basically using Moralis API. It's not gonna be the exact same value as the one we have from the Chainlink one, but it's faster and it's just basically give a good approximation for the user of how much deposit asset do they need to provide. So in this case, what we need is a Web3 API call right here, as you can see, to fetch the native token price. And in this case, the native token price that I define it above. Not yet, but we can use the use native token price if you're using the Ethereum boilerplate from scratch. Actually, I edited some stuff inside here so that I can fetch it manually instead of automatically like the one in Ethereum boilerplate. But here, basically, the native token price is going to be the result, the approximation, uh, the approximation result of from a deposit asset to Ethereum. So it's still kind of the reverse, but we can do that easily here by taking 1 over the native token price to get the approximated value. So here we get the which one here. So it's gonna fetch the native token price with the options right here. As you can see, we're going to be using different exchanges of the addresses. Of course, it's gonna be depending on the chains and deposit asset, but basically this is going to be the configuration where we'll be getting the price from various different uh, liquidity pools such as Uniswap, QuickSwap, and PancakeSwap, depending on the chains. So in this case, by default, and if we use Coven, we're just gonna use the Uniswap v3, and it's going to run the fetch native token price. And once that's done, the native token price variable right above here is going to output something. So when it outputs something, we can display it right here, right below here. There you go. So I already have this UI. You will deposit approximately how much? It depends. So yeah, let's just do that and go back. And here basically it reset our state again. So we need to approve again, but not to worry. Basically now when we choose a deposit asset using the Moralis Web3 API call, we'll be able to give an approximation of how much asset uh, do the user need to deposit. And in this case, it's gonna be the same calculation. So if there's one side, it's gonna be 0.01 Ethereum converted into link. If it's going to be two sides, we're going to multiply it by 2, 3. We're going to multiply it by 3. But basically, the bigger the number of sides is, the bigger of the number of deposit asset that we need to input into the into the betting game smart contract. And the reason why I designed this is basically the bigger the number of sides, the more possibility there is, and basically more risks, and it will basically to compensate that, the winner should be uh, given a chance to win a bigger winning from running the betting game. So that's just like my choice. Of course, if you want to build your own betting game, you could decide for your own self. But in this case, that's how it works. So we uh, we can approve it again, of course, but it will reset it again. So this time, before we approve that again, let's implement really quickly as well for the uh deposit one. So here, So to make it a bit quick, I think I can just copy the one I have right here. Oops. For the price converter, because it has a similar structure. So const, and then run deposit. And this is going to be is deposit loading. Deposit running. And the function name is going to be deposit. So we just need here deposit. And the contract address is going to be the betting game. I think, yeah, it should be the same as the one we have, the betting game that we just created here. Let me read it. So the contract address, yes, it should be the betting game smart contract address. So paste it. And then this one should be the same. We just need to change it here. Base address, quote address, and the token address is going to be from the ERC20 token address, JSON, chain ID, and then the deposited asset that have been chosen. That looks great. So now we just need to, oops, the ABI is still not correct. So let's disable this. I mean, uncomment that. Uncomment this one as well. So once that's done, basically we can betting game ABI, and then add this to the disable button. Is deposit loading? Is deposit running? Is deposit running? And is deposit loading? And then that should do the trick. And in here below, we'll need one more thing to implement the run deposit. So let's do that. Run deposit, and on success, we'll be able to set the deposit to true. I forgot if we have deposited. I think when I take a glance, there is, yes, but we haven't defined that is a deposit. So once that's done, we can basically, yeah, set deposit is true. Do we miss something? So I guess not. So in here, the use effect, we define our use effect that if is the deposit is true, then it will handle next. Handle next is basically move on to the next step, as similar to the one we have in the betting in the burn token section. So here, let's just do it really quickly before the game expired. So Chainlink, then approve, confirm, and then just wait for a few moments for the transaction to go through. And once it's successful, we should be able to deposit our asset successfully. into the smart contract, and we'll be able to see that as well through Etherscan. So oops, seems like it's throwing an error, so let's check it out. It could be probably because it expired, so not to worry. Let me check this out in Etherscan, and it's gonna tell us what the error is. Just wait for a moment. Yep, as you can see, the game has expired, unfortunately. The time of expiration that I gave is probably a bit too slow, but it, it's okay. Uh, let me try again. Let me try to burn another bed and create another game, and we'll be coming back. And this time we'll be testing the deposit functionality, and we should expect that everything is going smoothly. I'm not going to change any code while I'm jumping right here, so don't worry. Alright guys, so we're now back here, and I just created a new betting game smart contract, and here I have the smart contract here on Etherscan. Let's direct you to here, and I just copied the address to my VS Code. And now let's try it out and approve it. I just created like a few minutes ago. So this time we should be able to deposit it successfully. And I didn't change any code that we did previously. So not to worry. So let's see the test of the moment. It's going to take a while for approval. Okay, nice. So now just deposit. And there you go. Seems like it doesn't throw any error. So this time it should be good. And let's go back to the smart contract here and try to refresh it. This time we should be expecting a new transaction. Seems like it hasn't appeared yet. It's gonna take a while, so not to worry. There you go, guys. We did it. We just deposit around here, like as you can see, around 1.68284 something something something, and these are basically the value that is that we get from the Chainlink price converter, and seems like it's successful deposit. Let us check again here, and as you can see in here the Chainlink token, let us refresh again. There you go. Now there's just now originally 0.2 Chainlink, and I'll explain why it's there. But it's gonna be a topic in the next video, so don't worry about it. But right now, the most important thing is that we have just successfully deposited our link token, an ERC20 token, into our betting game smart contract. And now that's done, basically we'll be able to start play the game and let the chaining VRF determine the fate of whether we win the game or not. So, but before that, of course, we need to implement the use Web3 contract function as well, and it's gonna be in this play game here. It's still under the same game model folder components right here. So yeah, it's gonna be very similar. Let's just do it really quickly. Use Web3 contract, betting game ABI, and then I'm going to get the ABI here and have handle next so that we can go to the next one. And then let's define our use Web3 contract in this section to play the game. And so here really quickly, like run contract function, and we're going to rename it as run play. And then is loading is going to is play loading. Then is running is going to be is play running, and we're going to fetch it from use Web3 contract and we're going to use the ABI from betting game API. The function name is going to be play. The what else do we need? Oh yeah, the contract address is going to be the contract address that we of the betting game just now. And this case, I think I already copied, so I can just paste it here. And then the params is going to be, do we need any params? No, seems like there's no param, but regardless, for the use Web3 contract, they need the param. So if you have no parameters at all for your method function in the smart contract, just let it be an empty object like this one. So here then we are going to have so this is going to be is play loading or is play running, similar to the previous ones in deposit asset and burning tokens sections. And the dependency will also be is play loading and is play running. And once that's done, we will call the run play function right there, right down here on the onClick function. So just that easy. So run play, and when it's on success, let's use the handle next to go to the next the next step of the game, which is basically just saying that the game is finished. But yeah, let's do that. And as you can see here, at first the use Web3 contract could be a bit complicated, and especially if you haven't handled any smart contract interaction yet from the client side. But the more we go, basically it's just like doing the same thing over and over again, and you just basically needs this one React hook that is defined in the Ethereum boilerplate. It's very easy. Just need to input the right parameters, and you're basically good to go. It's very simple. So let's save this and try it out again. And yeah, let's try to bet on a game then. And cool. Seems like no error, so everything should be going fine. And in a moment here, we should be able, to see a play transaction on the Etherscan. So just wait for a moment because it could take a while. There you go. The play method is finally recorded on the Etherscan. So here, as you can see, basically, in here, it's using the Chainlink VRF to determine the winner here, and basically, because it's using the Chainlink VRF, it's gonna spend 0.1 link token to run the VRF and generate a random number for uh, the player here, for basically the creator or the challenger. And that's basically the reason why, if you see just now 0.2 link token in the beginning, it's because mainly we need 0.1 link for the creator and another 0.1 link token for the challenger. But that's out of the scope in this video on how we automatically send the link token to the smart contract, because of course if the user is not depositing link token, we still want to be able to allow the user to play the game without depositing any link token. It's basically just to enhance the user experience of the user. But that's gonna be in the next video, so don't worry about it. And once that's done, basically we just implemented the whole process and integrating the whole smart contract into our betting game implementation. There's also another one which is for the challenge one, which I already implemented right here. it's basically going to be the same as the one we have from the create game, where it's gonna burn some tokens. But yeah, basically, what's that? The only difference is that in here, the contract address that we use is gonna be the betting game address that is created, and not the betting game registry that is used in here. And so we're almost nearly done. The only thing we need is basically to display uh, the the created game on the on the uh, on the dashboard and on the betting page right here. So let me show you guys. Go back to the page, and oh yeah, this is basically the last page where we just need to close everything. So let's basically uh the bets page is basically to display all the betting game that we have created here. Of course, there's no right now because to do that we need the database, which we'll explore in the next video. This one as well, the same, but uh, at least for now, let's prepare the UI for displaying like the game that has been created. And in this case, let's just display the game that we just created here from the smart contract, which is this one. And to do that, basically, we already have a component here called game card, where basically it's gonna display all the information about the game. So in here, I sort of comment everything out because nothing is implemented yet. But as you can see, it will have the creator. It will tell us who's the challenger, who's how many sides, and etc., the status. So yeah, let's just do that. And in here we'll be using both the use Moralis Web3 API call to get the token metadata, and also the use Web3 contract. And it's gonna be very easy because basically all of these are just hooks that's provided by the Ethereum Boilerplate. In the case of your use Moralis Web3 API call, it's a hook that is provided by the React Moralis library, which here, let us see. We'll go to React Moralis. So basically just go to the GitHub if you want to read some documentations. And it's all very simple. Just one function will be able to solve all your problems. So use Moralis Web3 API call. I believe it's somewhere down here. Hang on a sec. Web3 API call, yeah, somewhere around here. So basically, all we need to do is just copy the format uh, of the code in this example in the docs, and use it in our code right here. Just simply like that. Copy. So use Moralis Web3 API call. I forgot we haven't imported everything, so better to uncomment all of this. And also use the Web3 contract, yes, because we're gonna use that. And then we are going to use the Moralis maybe a bit later. So we're just gonna focus on the Web3 API and use Web3 contract. So the first one will be the Web3 API call, the use Moralis Web3 API call. And in this case, what we want is to use the get let me see, get token metadata. As I remember, it's gonna be Web3 API dot token dot get token metadata. And if you guys are wondering like where to get those information, basically you need to check back to the docs.moralis .io in the Web3 API token here, where they provide most of the documentations on the Moralis SDK. And as you can see here, they have several sections such as the native account token and resolve. And in this case, I'm going to token because I want to get the token metadata. So basically, they're going to tell you like what kind of parameters are required and what are optional. And you just need to input the required one. So yeah, just like that. And we can go back to our code right here. For the parameters, I'm gonna uh, skip it right now because I'm going to call it actually manually from below. So not to worry about that. We can skip it here. So I'm not gonna use the error right here. And then the data, I believe I need that, yes. And then this one is going to be, let me see, because it will be based on the one of the function right below here. It's gonna be run get token metadata. Okay, so it's gonna be run get token metadata, and then once that's done, we can rename this as is get token metadata loading, and the data could be renamed as token metadata. And there you go, just save. And for the use Web3 contract here, oops, seems like we have another one for withdraw, but yeah, we can do that as well. So let's just do it really quickly. So it's gonna be const run contract function, and then is loading is running for the, oh yeah, I remember there's is fetching as well here. So it's running, and then use Web3 contract, where we'll be able to get the betting game and then the contract response. And once that's done, basically we need to input the ABIs for the betting game contract. So in here, it's gonna be betting game ABI. Is it? Oh no, I just need to input ABI right here, as you can see. So I don't need anything. Just need to delete this. Then function name is going to be get betting game info, and the contract address is going to be the card title, which here is basically one of the props that we're gonna pass. It's going to be on address format, so basically the address of the betting game that we created. So, and there will be no params, so just leave that empty. And this one is going to be run get betting game info is get betting game info loading, and this one is going to be is get betting game info running. So here in the is fetching, similarly we can just replace them by is get betting game info loading, or is get betting game info running, and then is Let me see what's another loading just now. I guess I need to check above. What is it? Is get token metadata loading. Okay. Token metadata fetching is get token metadata loading. And let's say first. And in here, we can basically just list all the variables inside there as dependency so that it updates when one of the value changes. Get token metadata fetching is get betting game info loading. So there you go. It's gonna be for the is fetching, and basically since we already defined the contract response from here, as you guys can see, contract response, we can uncommon all of this. Let's uncommon it really quickly. These are basically the information to determine whether the uh, as you can see, like, is the contract response valid? Is it the is it the creator? Whether they want to determine whether the address of something is a creator, or is this the challenger? Something like that. Then let me really quickly just comment all this out. There's a bunch of variables here to help us basically for the UI. And once that's done, we'll want to use this use effect. There's 1 and 2, and the first one is gonna be basically when there's the card title and when the Moralis SDK is initialized, and we get this basically from the use Moralis hooks right here. We will want to run the get betting game info to get basically the contract response value onto each of this so that we can display it on our UI, on our game card. So just uncommon that one and this one as well. And this one is basically so if the contract response is valid and the contract response 5, the fifth value of the contract response, which I quite forgot what is that. Let me check really quickly. So sorry. So the fifth one right here is oh, I see. It's basically the token address, I think it is the token address that is the deposit token asset. So it corresponds to the link token, DAI token, and the unit token that is being deposited into the smart contract, and that's one of the data that can be fetched as well. And in here, basically, we want to get the token metadata, like the symbols, so that we can display it on our UI. And once that's done, I believe here we might need this use moment as well. Basically, moment libraries to help us to format some timings. And yeah, all looks really good. So here, mm, let's just uncommon all of this then and see what the result will be. So save. Oops, seems a bit of error there. Okay, so just minor. Save. Oops, seems like I didn't. Maybe I still comment a bunch of stuff up here. Okay, so what I need is basically just to here. First thing is that, like, let's resolve the wallet address and save it. it should disappear. The use effect should be imported here. Use effect. And then the component typography should be from end design. Then get token metadata. Okay, so it's just naming. The next one is space. Yes. All right. Great. So the only one is this one. I think get token metadata will be this one. So just save it. And then let's also uncommon everything here. So including the handle challenge. It's nothing much. Basically, it's to help us open the model that where we create the game and something like that. But for the challenger part, so there you go. And then is withdraw running? Is withdraw. So those are gonna be on the uh, use Web3 contract here to withdraw. So basically, we just need to define it really quickly, but we're not gonna go and test displaying the UI first, then go back to the withdraw function after this. So here, let's just define it really quickly so we don't get any error. Just loading, withdraw loading, and then is running, and then is withdraw running, and then equals to use Web3 contract, and then it's going to withdraw. So the withdraw one is going to be the ABI having the, oh yeah, I forgot. It's just ABI, and then the function name is withdraw, and then the contract address is going to be the contract address of the card title, which will later replace with a betting game contracts address. And then the last one will be the params, which there is none, but we'll just keep it empty. And there you go. The error all should be disappearing, and this time we'll be able to display our game using this game card component. And to do that, we'll display it first in the we'll first display it in the bets page. So here, go under the pages directory, and then me bets. And here, let me close this again. And in this case, let's input the betting game data to be the contract address. Oops. I guess I copied something before, but let's just quickly like copy this address and input it into the array. So save this one. Hopefully there's no error. So there you go. Just like that, it will basically render our UI. And the only thing that we need to handle is basically to get to use the use Web3 contract function to fetch the data from the betting game smart contract. And yeah, just easy as that. Just a few lines of code, and you can do this really quickly. Of course, for the UI, it's your own preference how you structure them. It might take longer than uh, defining than using the use Web3 contract. But as you can see, if you have everything in place, basically in just a few lines of code, you'll be able to get to use the use Web3 contract to get uh, the betting game data from the betting game smart contract. And also, of course, easily we can translate the we can get all the token metadata from using Moralis Web3 API call, which they provided directly out of the box using React Moralis library, and it basically uh, helps you to easily fetch the token metadata such as name, symbol, and maybe decimals and other information so that you can display it into your dApp right here. Such as here, I displayed the symbol and the name of the token themselves, just that easy. And basically here, once that's done, right now seems like the game already expired, but other than that, basically here we can view the details of the contract themselves. And yeah, this is basically the same contract that we did before. As you can see, we play it and deposit on it. So yeah, just that simple. And basically that's how we integrate our smart contract into our dApp use Web3 contract using Web3 API call. Basically, all the Moralis functionality and Ethereum Boilerplate makes it very easy to integrate our smart contracts to our dApp in just a few lines of code. So hopefully you guys learn a lot from this video, and in the next video we'll be exploring how to enhance our dApp by using Moralis DB and some event syncing functionality provided by Moralis DB as well, and it's all gonna be real time and cross-chain by default. So stay tuned and hope to see you guys in the next video. If you guys still have any questions regarding the DeFi betting platform we just built or the tutorial itself, make sure to go to this forum at forummoralis.io, and I'll put the forum link down in the description, and here we'll help you with your questions as soon as possible. Also, make sure to like and subscribe to our YouTube channel if you want to see more Web3 tutorials like this. Thank you guys so much for watching, and I'll see you guys soon. Bye bye. Welcome back to the channel, guys, and this is the 7th video of the tutorial series where we'll be finishing our DeFi betting platform using Moralis and Chainlink, and we're basically very close to done because we already built our smart contracts, deployed into Coven testnet, and we also already uh, uh, integrate the smart contract functionality with Moralis into our client app in the previous video. So we're basically nearly done. The only thing that is left is basically we want to enhance the UI experience basically by using event syncing, and with Moralis basically this all can be done automatically. So now, for those who don't know what is event, is basically it's something that we use in smart contracts to emit, to basically indicate that something has happened before or some kind of transaction has happened or has finished. Like if you remember when we're coding the smart contract in the first few videos, like we did define some events here. This is the betting game registry.sol that we deployed before, and as you can see here below, let me check it out. There should be some event right here. Oh yeah, this one, just one, which is the betting game created event. Basically, we emit this event when we're creating a new game. Now, this is basically used here to indicate that when all these transactions, all these operations are completed and we emit this event, we'll be able to catch this event in the client side so that we know that the transaction has gone through, or basically to know that the betting game has been really created. But uh, other than notify, can be used to notify the client dApp themselves. The other purpose of having an event is basically to be an alternative storage that is cheaper compared to storing data on some storage variables such as this one, because storage variables are much more expensive and it could cost a lot of gas fees just to change the data in within all these variables. So that's one of the purpose as well. And by using this and using Moralis to sync our event, we'll be able to fetch all the data, all the data that is stored in this events that was emitted before. And as you can see, there are a bunch of datas in the betting game created, such as betting game count. This one is msg.sender. As I remember, let us check above here for better view, which is the betting game ID is the first one, the creator, the size, and the betting game address. So basically, by syncing our events with Moralis DB, automatically, basically, we'll be able to fetch all this data and put it in a DB instantly and quickly, and we don't need to do anything else. So in order to do that really quickly, uh, let us just go to your Moralis admin page again. Uh, and in here, go to view details and go to the sync tab. And in here, I already have a couple of contract events that we can use. But if you don't have one yet, basically go here, add new sync and watch the contract events that you want to watch. So basically, then choose the chain where you uh wanna look the wanna look into the events of. So in this case, we're going to use Coven and then give any description that you want here. In case you wanna sync the historical events, then you can check on this. Otherwise, you don't need to check it. But the new events that is emitted going to be synced automatically, but the older one that was emitted before are not going to be included in the database. In our case, we need that. And the topic here, we're going to get it in here in the events. As you can see, they're going to categorize what kind of events that is emitted from the smart contract. In our case, the betting game registry only has one event, which is this one. And as you can see here, basically, the topic is going to be this one right over here. So just copy this, and this is basically gonna be unique. So once you copy this, and you wanna and you do it on another chain, you just need to have this copy this one topic and paste it onto here, this one. And another one will be the ABI. The ABI will be the ABI of the betting game created event ABI itself. So you need to go back to your contracts folder right here in the SRC and check the betting game registry and try to search for the betting game created event. As you can see here, the type is event, so keep that in mind because we're trying to detect events here and not functions. So yeah, just copy this part, the whole event. There you go. And then paste it onto the Moralis admin ABI page right here. And the address will be the address of the contract that we deployed, which is the betting game registry. And the table name will be the table name of the DB where we want to store all the events that is going to be recorded, and the historical event as well if we choose this thing historical. So yeah, just that simple. For me, I already have them all. So this one is for Coven. I also have one for Polygon Mumbai and BSD testnet. All the configurations are very similar, Basically, what we need, what's the difference is gonna be just the address, where you need to input the address of the deployed smart contract correspondingly to the blockchain themselves. So once that's done, just confirm and it will basically save and create a new DB table uh, for you on the Moralis server. And keep in mind, although you can edit these information later again, but once you edit the information, basically you need to create a new table. So you need a new name for the table name in case you are editing something uh, for the event syncing event configuration. But basically, once that's done, you can just go to the dashboard here, and here will be the betting game created database, where here, as you can see here, it's basically syncing all the data from the event itself, and it basically provide us all the data that is given here, as you can see, like the betting game creator sites and betting game address. And if we check back here to the DB, you will see betting game ID. Let me see here, betting game address, creator, and also the site should be somewhere around here. There you go. And the rest uh, of the column is gonna be related to Ethereum transaction, which we can fetch as well. So yeah, by using this, basically, we'll be able to display the betting game, all the betting game that we have created, or maybe even the betting game that have been created by other people, so we can bet against them. But and yeah, so let's just do that. Basically, once you sync the event, let's add some use Moralis query to query the database and display all the betting game that has been created on the bets page and also the dashboard page right here. And yeah, as I mentioned, this work cross-chain by default, so very easy configuration. You just need to uh, uh, g- do it a couple more times here on the event sync. But other than that, it shouldn't take like a few minutes to configure them. And once those are configured, basically every new event emitted will be recorded by the Moralis DB automatically. So basically, to complete that, let's first go to uh the bets page first. The bets the bets page. And in here, for now, we only have the betting game data, returning the address of this betting game smart contract that we deployed in the previous tutorial. But we would like to basically make it return into a number of betting game that we have created by the creator themselves. So here, let me uh, show you a bit. But here, basically on the slash bets, on the bets page, basically we want to display all the betting game that has been created by the creator. So here the creator should be you, which is the address that I have. And in the dashboard, we would like to do the same, but instead we'll be displaying the games that is not created by the creator or the holder of the wallet in here, so they can bet against other people. So yeah, just to do that really quickly, basically let's go back here and then use Moralis query. And to do that, this is going to be a hook function from React Moralis. So just go to React Moralis, React Moralis GitHub repository, and then here you have a section for use Moralis query, and this use Moralis query is basically gonna help us fetch the data from the Moralis DB that I just showed you before. And in this case, it's going to be betting game created token. So just to do that, first let's copy this part because we want to do some filtering as well. So let's copy, and then betting game created Coven. And then here we would like to filter them based on the wallet address because we want it to the creator to be equal. As you remember, there's a creator column here. The wallet address, and then in here what else do we want? Dot equal creator wallet address, and we don't want it to be limited, but we do want it to be descending depending on the time created. So as I remember, like, let's see here. Oops, sorry. So yeah, created at, let me check. There must be a, oh, there you go. A column for created at, basically when did the game is created. And also I just remember that we need to check whether the betting game contract has been really created, or whether it is confirmed or not, because a transaction could still fail, you know, in some ways. And if it's not confirmed, there will be no betting game smart contract created, and we don't want to fetch that. So to do that, we will also, this is going to be created at, and this is going to be dot equal the confirm, and this is going to be true. And let's check it really quickly here to console log the data. And in here, let's just take the data. Oops, seems like we haven't imported use Moralis query here. So there you go. And also the use Moralis dApp. There you go. So once that's done, let's go back here to our dApp. Oops. And refresh. Hopefully there's no error. Okay. Query dot equal. Oops. I guess it's not equal. It should be equal to. My bad. Yep, equal to and equal to. So there you go. Once that's done, boom. Like, we just, oh yeah, I almost forgot. We haven't put it in the betting game data variable to display it in the UI, but we should we just console log it, so we should get some result, and boom, just a few lines of code, and we already get the data from our event syncing DB, and just that really easily. And basically the data can be get into in this attributes field, and there you go, like the creator, the betting game ID, the betting game address, everything, all the information basically are going to be there. So yeah, we already got this, so let's process this data to be rendered on the UI in the game card here, as you can see. So really quickly, let's go to, by the way, if it's a bit too small, let me increase the size of the console there. And go to bets again. Yep. And then here we'll edit our betting game data into the into using this data variable. So yeah, let's just do that really quickly. Oh, by the way, uh, so in order to fetch this data repeatedly when something changes, so there's also a dependency variable, such as the one that has an use memo or use effect from the use Moralis query, and we are going to use its initialize and the wallet address. So in case that something those two variables change, we want the use Moralis query to refetch the data again. Wallet address, there you go. Oops. So yeah, that's good. And once that's done, we are going to use the data as our dependency in this betting game data, and destructure the data into, let us see back again in here, what do we have? So oh yeah, I just remembered this is gonna be an array, so let's map it. Let's use some mapping. So here it should be data.map. It's gonna be an array, and it's gonna take the input, the object input that we just saw just now individually, and let's restructure them this way. So cons, let's take the attributes, if you guys still remember, from the individual objects in the array. So yeah, this is gonna be the object. So this is what's gonna be passed on the variable, and we're gonna destructure the attributes object and get the betting game address, because that's what's gonna be passed down into uh, the the game card components. Card title here. Card title should be an address, as you can see. So yeah, just like that, and we are going to destructure this again and take the betting game address and attributes, and I'm going to use this just for safety in case the D and the attributes are empty or undefined. And once that's done, let's return the betting game address themselves, and basically the end result of this mapping is going to be an array of the betting game address itself. So to verify that, let's console log as well. So we just need to console log this part. Go back to our app, and it seems like it's working, so that's great. And there you go. So it's gonna be an array of addresses, and the end result is basically something like that. And just in just a few minutes, we already integrate event syncing and Moralis DB functionality to display all the betting game that has been created in the betting game registry itself. And of course, you know, since we're using mapping, it's gonna basically just render everything that has been created. And yeah, just that really simple, that really quickly, just a few lines of code can enhance uh your dApp uh enormously by using the Moralis SDK. And yeah, so we just did that for the bets page. So let's do it the same as well for the dashboard page right here. So really quickly, we can just copy this page here. Copy the code and then go to the dashboard and paste it in here as well. But instead of creator, it's going to be not equal to creator as I remember, I guess. If not, we shall check again, but something like so. And this should be something sort of the same as well. So let's just copy this code as well. And I'm just gonna delete this, make it clean. And then let's replace the betting game data variable with this one. Oops, I forgot to uncomment this. So there you go. Very easily is initialized. It's not. Is what is going on here is initialized. Maybe there's some kind of typo. Yes, there's typo here. It should be is initialized. There you go. And that seems correct. So in this case, boom, just like that. And this one, we basically fetch all the game that has been created by other people that is not by me. As you can see, the creator is an address that is not my address right now, but I of course could be the challenger of the game. And so yeah, just like that, and boom, just a few lines of code, and we already enhance our app like 100 times better than before. So this is basically uh, improves the user experience definitely much more. So once that's done, the other place where we'll need to use the use Moralis query is gonna be the create game model right here, because when first creating the betting game smart contract, basically we need to fetch the newly created betting game address, because we want to pass it down into the deposit use Web3 contract before, and also for playing the game as well, because we don't want to do it as the previous tutorial where we're basically trying to search what's the betting game address on Etherscan and check on the event and something like that, because the user will not do that. We need to automate all this process in our code. So to do that very easily as well, let's go back to our code and betting. So it's gonna be on the burn token part here. I already make a little comment. So here, let us also use Moralis query. So I guess just copy this as well. But in this case, we don't want to filter them based on the creator, because basically there's gonna be a lot of creator. I mean, there's gonna be a lot of games that can be created by multiple, by a single creator. So in this case, what we need is the transaction hash to filter the query by a transaction hash. Let us go back to the Moralis DB here. And as you can see, the transaction hash right there, we have an entry for that. And basically, once we did the transaction from creating the game, we'll be able to fetch the betting game based on the based on the transaction hash that has been registered. So yeah, to do that, let's just do that really quickly. And this is going to be, let's see. Yep, transaction hash, right? And then I already have a use state for transaction hash as well right here, which we can use. So this is going to be transaction hash state, which we are going to get from somewhere down here. Oh, yeah, no, not down there, but on the use effect that I mentioned before. So this is going to be the betting game data. So here, as you can see, it's going to destructure the attributes again and then get the betting game address res from the attributes and then input it in the handle betting game address, which we should see on here. It is going to be handle betting game address is going to set the betting game address for the for this whole component here, because we don't just want to use it on the first step here for the burn token, but we're going to use the betting game address, as you can see, the betting game address variable on the deposit asset and the play game as well. So to do that, let's just really quickly like, so I guess since it's the name is betting game data here, let me change it into betting game data as well. And then uncomment this. And also this one for sure. And then once that's done, then we just need to save it. Oops. We also need to, is initialized, it's not defined. Okay, gotcha. So we basically, let's use is initialize here. And also wallet address, I guess, is going to be from the use Moralis dApp. Right. There you go. Oh, and I almost forgot to set the transaction hash. Uh, after creating the game. So yeah, let's just do that. I sort of forgot what's gonna be the result here, but basically on success have one parameter result, which is gonna be the result of the transaction where we could get the transaction hash. But let's console.log it first, and then we shall see. So once that's done, let's go back to our dApp and try to create a new empty game. So approve and confirm. Once that's done, let's burn our token, our bet token, so that we'll be able to create a new game, a new betting game smart contract using the betting game registry. So yeah, let's burn it. It's gonna take a few moments. So there you go. Once that's done, let us hmm let us find where's the transaction hash. Oh yeah, there you go. So basically this is the result variable that we get from on success. And once we get that, basically we need to input this transaction hash into the state into the React state that I mentioned before. So just const transaction hash, and then let's set the transaction hash into the transaction hash. So once that is done, we should be able to uh, get the what's that? To be able to get uh, get I'm sorry, we'll be able to get the betting game address from the use Moralis query here. And then, oops, I almost forgot. Let's make transaction hash as the variable as well, because we wanted to trigger another refetching once the transaction hash is completed. But yeah, once we fetch and the betting game return a result, it will be called in the use effect here, where you can see if the betting game data is not undefined or null, and then the length is 1, and also if the betting game address uh, is empty. So it's going to be only empty when it is on the creator side where we're creating the game. So yeah, then it's gonna take the betting game data, the attributes, and set the betting game address right here to be set in this function right here. So set betting game address, so it can be used on the other steps of creating the betting game. So just like that, let's test it out really quickly. Save and go back to our browser right here. And this time let's burn it again. So it's gonna create basically create another game. Oops, I forgot since we didn't approve the burning. So I guess let's uh, create another game right here. Approve it, confirm, and then this time burn it and create a new game. Hopefully this time we'll be able, if it's successful, we'll be able to move on to the next step immediately. Oops, seems like something is not right. So let's try to console log the betting game data for now. Seems like it's empty. So if we go back to the Moralis admin and check the latest, I see. So it's not gonna be confirmed immediately. So definitely needs to wait for a moment. So I guess in order to jump the hurdle for now, let's delete this equal to confirm. But in some ways, it's best to uh, I guess to wait until the confirmation is true, and then we fetch it again, then move on to the next step. But let's delete that for now. And there you go. Seems like it goes to the next step and fetch successfully. But this time, let's try to create a new one again so that we really know that the flow is really, really working and not just by accidents. So take a few moments to approve it again. And burn the token. Confirm. And let's wait until the game is created. Hopefully this time we'll be moving to the second step immediately. Okay, there still seem to be some issue here. All right, guys. So, sorry that I need to jump because apparently there are still some hiccups in in the code a bit. So, it kind of forced me to look back to my original code. So in this case, actually, we don't really need this one. Is initialize and this one. And let's see. So it's gonna be betting game create coven as well. Now this I don't think should make any difference, but that's what my original code in the main branch is. So let's let's try it out then. Okay guys, sorry that I need to kind of jump and cut some parts of the video because I found out that I make a little bit of mistakes on my code that I miss. So in here, let me explain what I changed. So in here, basically this time I simplified the querying to just equal to transaction hash, uh, no dot descending created at anymore. As well, it's quite unnecessary actually. And in this case, I also removed the is initialized and wallet address in the dependency array, but that's not actually the really big problem. The big problems comes in here. If you see, uh, I basically forgot this betting game data and betting game address uh, parameters in my code, which was just kind of silly, but yeah, since I didn't include it just now, that means like even though we refetch the betting game data from the Moralis query, it will not update this use effect, will not run the function that we have in this use effect to move on to the next step of creating the game. And so that's a crucial little part of the detail. Also, I edit is betting game created loading and fetching right here. As you can see, it's basically from the use Moralis query, but it's not really a big deal, just some nice touch for the UI. So once those are in, let's have a test on it again. This time, everything should be uh, good, and we should be able to move automatically to the next step once the burning, creating the new smart contract is done. So let's burn it and create a new game, and boom, just like that. And we are successfully integrating the use Moralis query into the burn token part of our client app. And in this case, the only little things that we need to change is basically to to change uh, the the betting game address in the deposit ERC20 token into a variable instead of hard coding it, if you still remember. So in this case, this will be betting game address here because I pass it down in the props. So in here, the approve, we shall have it as the betting game address. And this one should be a betting game address as well. And that should be good. Of course, the play game should do similar things. So here, let's uncomment this really quickly. Betting game address. Save. And then I remember in the burn token, we also need to use the betting game address in case we are dealing with the challenger. So in this case, instead, as I mentioned, instead of approving the betting game registry, if it's a creator, we're going to approve the betting game address itself. So in this case, we're just going to use like this is creator. The spender is going to be the betting game registry. In the case of it is the creator that is going to create a game. But in the case of challenger, it's going to be the betting game address. So save that. Let's go back to here, and hopefully all the workflow should be all going smooth. So let's confirm, and then similarly just deposit the asset. It's gonna automatically access the funds, the Chainlink funds in your user wallet. So just click confirm and wait for a moment till everything goes through, and we should be going to the next step to bet. And there you go. Now it's done. Let's play the game. And boom. Awesome. Seems no error. So let's just wait for a few moments, and boom, done, close, and there you go. Uh the whole workflow, the whole game flow for creating a new betting game. And of course here, uh if we were going to change our uh address into another one, so here I have a second address. Once it change, it should be able to fetch all this new games that I just created before. And of course I can be a challenger, but in this case we're just basically gonna follow the same process as before, where we're approving, burn some bet. But in this case we're gonna register as a challenger instead of creating a new game, and then deposit and also play the game itself. But we're not going to do that, so let's just refresh. And then yeah, so just like that, and we already integrated event syncing and the Moralis DB query into our client dApp, and basically now we can now we are able to create a game seamlessly for user, from the beginning till the end, till a challenger comes, and basically until both the creator and the challenger play the game and bet on the blockchain, and eventually will be able to withdraw the winning for themselves. Now that we've finished the event syncing and Moralis DB query integration to our React dApp, let's do some more advanced functionality from the server side this time. And to do that, Moralis offers us cloud functions, as you can see here, where we'll be able to write our backend code once and be used in multiple platforms. That is, if we have like web dApps, or maybe mobile dApps, desktop dApps, all we can just write the backend code here without setting up our own backend uh, project. So it's also going to be useful in our case, as I'll explain in a bit, that because it provides us the functionality to make a scheduled cron job and also a trigger function when there is a new event that is emitted from the smart contract. So to get the code for the cloud function, actually I already have it in our project here under the cloud folder. If you go to src folder, and there we have, first is the after save, and the second one is the job function. And I'm gonna explain to you one by one. So the first one is gonna be the after save, and we're just gonna focus here from line 19. So basically here the after save cloud function basically enables us to trigger this functionality inside the function right after uh, a new entry is saved into a DB. And as you can see here, the DB is a variable. That is because we would like to make multiples of the same functionality on different chains. As you can see, this is basically the betting game created Coven for the Coven testnet, then BSC testnet and Polygon Mumbai. But these are basically the DB entry that is going to be entered on this after save. And basically, what we want to do is that when a new entry or a new event is emitted from the smart contract, when a new betting game smart contract is created, we would like to do all this functionality below. And here, let me explain. Basically, here, as you can see, first it's gonna try to get the uh, first it's gonna try to get the latest object and check what's the confirmed status. So this is basically gonna be called twice to check whether the transaction has been confirmed or not. I mean, the event has been confirmed or not, and the first one is not gonna be confirmed, so it's gonna be skipped. But the second one, it's going to be called when the confirmed variable is going to be true, and that's where here all the functionality is going to be called. And here, basically, other than that, we're going to get the transfer address for the betting game address. This betting game address basically refers to the betting game address column, if you guys remember, from the betting game create Coven. So here, betting game address, basically the address of the betting game that is created by the betting game registry. So we get that and input it into the transfer address variable. And once we have the transfer address value, we will want to trigger an HTTP request from the cloud, opposed to call a URL, which is also actually provided up here above. So the URL here are all OpenZeppelin Defender URL. They are basically webhooks, and we're going to use them to basically send some link token to our smart contract, because as you remember, when using Chainlink VRF, we need some link token to run the randomness functionality. So in this case, basically, we're going to be the provider of link token instead of the user themselves. Of course, like if the user is depositing a link token, then they might not need one, but that's just basically limit the user to just deposit some link tokens instead of any other tokens, because then they cannot run the randomness function to determine the winner. So yeah, basically these are gonna call OpenZeppelin Defender function, which we're gonna explore as well how to set it up. It's gonna be really easy, so not to worry. So as you can see, once that's done, we're just gonna need to include the transfer address in the body, and the headers is gonna be content type application.json. And of course, since this is a webhook, it's gonna be a poach HTTPS request. So remember that. And this follow redirects is optional. And once that's basically once the HTTP request is called, then it will call a callback function right here, where here, as you can see, that basically it's gonna if it's successful, it's gonna log that the link token that is sent is successful in this, and the network, it's gonna detect the network as well. The network, we wrote it down ourselves as well in the JSON, so no need to worry about that. And then if it gets error right here, it's gonna log an error that the request has failed with response status, and also the JSON stringifies version of the HTTPS response. But basically, just like that, and we'll be able to send some link tokens into the betting game smart contracts that we just created, so that user, the creator, and the challenger that are participating in the betting game, they'll be able to play the game without needing to deposit any link token by themselves. So yeah, that's the first one, where we'll be using the trigger functionality, the after save trigger functionality. There are other trigger functions as well, which you guys can check in the docs. So the second one will be a scheduled jobs, or you can think of it like a cron job. And in here, I define the name of the job as send low funds email. And in this case, basically, because we're going to send some link token from Open Zeppelin Defender, which is basically from another Ethereum address, we wanna make some kind of like checking where we'll be able to watch the address and see whether the link token balance in each of this address are still sufficient or not. Because of course, if it's not sufficient, then even if we call the after save function here, it will not send any link token, and basically our dApp will not work as properly as it should be. So yeah, those are the things that we need to do. Just walk you through a bit here. Similarly, so the faucet address is gonna be provided by the Open Zeppelin Defender, as we will see after this. And then we're basically going to query from the Moralis DB, where the address should be the faucet address, and this is basically to check the link token balance from this address on each network. And then once we find it, then we basically get the balance and parse it into an integer type. And then we'll check whether the balance is below 20 link token or not. If it does, then we're gonna send an email to any admin email that we have as the admin of the dApp itself, and to just say basically that our link balance in certain faucets are getting drained low. So yeah, basically those are the functionality that we would like to implement. Of course, we already have the code, so you can just copy both from both files, and then open your Cloud Functions here and save it. And once that's done, then basically you'll be able to do all to utilize all this advanced functionality within your dApp pretty easily. And of course, because we are going to, as you can see, to watch some address using the cloud.job, and also check the balance every once in a while, we would like to basically want to watch the address. So to do that, sync and watch address and put any chain you want. So example Coven, and then it here is gonna be the address of the link faucet that we're gonna set up after this with Open Zeppelin Defender. And of course, it's optional whether you want to sync the historical or not. But yeah, other than that, basically you just need to input the address and confirm, and it's gonna take a while to sync and watch the address. But once that's done, then we are ready to move on to the Defender part of Open Zeppelin, where we're gonna set up some link faucet. It's kind of like a link faucet. It's not exactly like one. But yeah, basically to do that, go to defender.openzeppelin.com and then sign up for a new account. And once you have an account, you should be able to go to this dashboard. Basically, here the functionality that we want to use from OpenZeppelin Defender is the OpenZeppelin Relay and also OpenZeppelin Auto Task. And let me explain it really, really quickly. So, OpenZeppelin Relay basically set you up a relayer for you. A relayer, you can think of it like some kind of Ethereum address where you can uh, sign sign a transaction on behalf of your user, so your user doesn't need to trigger some MetaMask. But in this case, basically, yeah, you can trigger some smart contracts call using this Ethereum address instead of your user Ethereum's address. And as you can see here, I have the Ethereum address here on Coven, BSC testnet, and Mumbai. You can of course just set up one, but yeah, this is just an example. And to set up one, of course, it's gonna be very easy. You just need to name what your relayer is, and then choose what kind of testnet, or maybe you want to use it in production. Then it's gonna be one of the mainnets, and just like that, and create, and basically in a few moments it's gonna create a new relayer for you. But keep in mind that you need one relayer for each network. So once that's done, then you basically need to provide some Ethereum and also some link tokens into your smart contract, because in order to sign some transaction, it still needs to pay some gas fees. Basically, in this case, like, we want to send link tokens uh, using this relayer, or you can think of it like a wallet. And here, as you can see, basically every time we uh, trigger a transfer link token, it's gonna of course pay some gas fees from this ether balance within this address. And yeah, then the Chainlink token of course is going to decrease over time. So yeah, just basically just simple like that. Just set up your relayer. Once that's done, you have the address, deposit some testnet ETH and also testnet link, and you're basically good to go. Similar if you want to do it in other chains as well. But to do the sending link one, we will need the auto task. Auto task is basically will enable you to automate your smart contract workflow. This could be like making some scheduled smart contract call, but of course you can also trigger it using an HTTP request as well, or webhook, as we did just now in the cloud function right here. As you remember, we have some URLs which we can trigger, and yeah, that's one of the functionality that came from auto task. And to set up one, basically you need to very simple, just do just follow the instruction here, basically like name your auto task anything you want, and then you can choose whether you want it to be scheduled. And there are some other advanced functionality provided by OpenZeppelin Defender, but in this case we're just gonna use webhook, and from there we're gonna choose which link faucet where we wanna send the link token, basically trigger the link token functionality from. And from there, basically, yeah, just choose a relayer. For example, this one, like for BSC testnet. And then for the code is gonna be where the implementation, where we're going to ask OpenZeppelin Defender auto tasks to execute what kind of functionality on behalf of our relayer. So in this case, I also already provided a Defender code here, so you guys can just copy them. So here you go. So as you can see, basically above here, it's just going to be the ERC20 token ABI. And then I'm going to use the Defender Relay Provider and the Web3. You guys don't need to know so much about it. Basically, just copy everything. And in here, as you can see, if you know a bit of Web3.js, here we're calling the ERC20 contract on a variable and then transfer it into the transfer address that we get from the body that here, if we go back to the cloud function, it's going to be on this body, as you can see, the transfer address. And this is, as I mentioned before, is going to be the betting game address that we just created. So once that's done, then it's gonna send transfer around 0.2 link token to the smart contract that we want, the transfer address. And keep in mind that, of course, since VRF on Chainlink, they on different networks they use different fees. So in this case on Coven, they're gonna use 0.1 for each VRF call. So we have 0.2, but in other networks you need to adjust the amount basically to what they have from the documentation. And also don't forget to change this into the address of the Chainlink token corresponding to the network itself as well. In this case, this is the Coven, so I can basically just copy this code and add it right here, and you don't need to think much about it. Oh, and of course, like if you're gonna do it on Coven, then you need to choose the Coven one as well. So keep in mind that. But once that's done, it's gonna create an auto task for us as well. It's gonna take a while, so but I'm just gonna cancel this one. Okay. So once you created a relayer on the Coven testnet, I mean an auto task and relayer to send link tokens to the smart contracts. Basically, you can get this webhook URI because we set this up to be webhook based instead of being scheduled. So just copy this and then paste it in the cloud function URL right here as my example. And once that's done, basically it's gonna trigger an after save trigger trigger all this functionality below where it will send link tokens from our relayer here, the link faucet right here, using the webhook URI that we just defined here. So just simple as that. And yeah, basically just like that, and you'll be able to send link token from your behalf to the newly created betting game address that the user, the creator, or the challenger have. So yeah, that's it. And the second one, as I mentioned, is basically just kind of like a reminder to check whether the funds in our Defender relayer is low or not, because like if it's too low, then you might need to supply more link tokens into your relayer. So that's why in here, basically, the only important thing that you need to change is gonna be the faucet address. The faucet address is basically gonna be this. Luckily for me, I have the same for 3 of my faucets, my relayers. So I just paste this once and then like kind of like loop it through using the for each function here on the 3 networks and check. In here the balance is less than 50 link, but it doesn't matter. Basically this number you can edit by yourself, like like what is the minimum link token that must exist in each faucet, and if it gets too low, basically it will send an email here using the Moralis Cloud function, send email to the address that you want, preferably your admin address, and the subject is gonna be this one. The HTML content is going to be this, and once that's done, basically you're good to go. And oh, I almost forgot, since we're basically using one of the email functionality below here, we also need to set up one more thing before we go. So it's gonna be going to your view details here and go to the settings. And basically, in order for you to be able to use the email functionality from the cloud functions, you need to set up your SendGrid account and copy your credentials right here, your API key, and of course your from email where you want to send the email to. And once that's done, then you're basically good to go, and you'll be able to send some email to your smart. You'll be able to send some link tokens automatically. It's gonna be handled automatically by the cloud function, and also every once in a while, send email your to your admin email to check whether the faucet is low balance or not. And yeah, so that's it. One last thing is probably gonna be setting up the cloud function. No, sorry, I mean the scheduled jobs, because although we already set up the jobs right here, as you can see, the Moralis Cloud.job, we didn't actually uh, schedule it. So in your case, you might need to add to add a new scheduled job, and to do that really quickly, you just of course go to your dashboard and DB here. So this is gonna be the Moralis dashboard, and then from there go to jobs, and then the trigger jobs, as you can see here. Let me show you again. Scheduled jobs in this section. And once that's done, basically then from here, you'll be able to schedule a new job, give a description for yourself of what the job is going to do, pick the job that you want to be scheduled. In this case, it's going to be the sync. I guess since I already registered my job, then I don't need it anymore. But it should be this one, the send low funds email. The same name as I gave on the cloud function right here. So basically here, as you can see, I already set up one. So let's just check this one. So in here, I give the description as sending a link low funds reminder email, and then the cloud job, I choose it as the send low funds email that we just set up in the cloud functions. And once that's done, we don't need any parameters for this. And so just schedule the job, when do you want it to start, and whether it should repeat, how should it repeat, and etc, etc. And once all those configurations seems correct to you, then just click on schedule, and basically you're done and your job is going to be scheduled. So yeah, that's it gonna be for the cloud function, and hopefully you learn a lot from setting up all this advanced functionality, from event syncing, from you using Moralis query DB, and also the cloud functions and scheduling jobs, and etc, etc. And thank you guys so much for watching, and I hope to see you guys soon in the next video. If you guys still have any questions regarding the DeFi betting platform we just built or the tutorial itself, make sure to go to this forum at forummoralis.io, and I'll put the forum link down in the description, and here we'll help you with your questions as soon as possible. Also, make sure to like and subscribe to our YouTube channel if you want to see more Web3 tutorials like this. Thank you guys so much for watching, and I'll see you guys soon. Bye bye. Hey guys, welcome back to the channel, and congrats if you already reached this far in the tutorial series where we're building a full-fledged DeFi betting platform, because this is gonna be the last video in the series where finally we'll be deploying our dApp into the internet directly, where people can use it, use your dApp on production. So basically, to do that, it's gonna be very easy. In this case, we're going to use the Moralis admin CLI, and basically it's a tool where we can access the Moralis admin server, which is the dashboard that we have been exploring a lot in the last video, through our CLI directly. And as you can see here, there are a bunch of tools, but the one that we want to focus is gonna be deploying our dApp directly into the Moralis server. And to do that, it's going to be very easy. So here, first, before we start, I guess I need to mention that I make a bit of changes to completely make our dApp to be fully cross-chain, because we have created some database here. Let me go to here first, list database.json, where basically the betting game created event sync database have different names. For Coven, it's gonna be betting game create Coven. The BSC has its own, and the Polygon Mumbai has its own as well. So in this case, for all the use Moralis query, you guys can basically just change the variable instead of just the usual betting game create Coven to be database and then chain ID, indexing the chain ID, and take the betting game created field. And the database is going to import the list database.json from under the list folder right here, and basically just do the same for all the use Moralis query that we did in the previous video, as you can see in the dashboard and the betting in the bets page as well. And lastly, put the chain ID, because we want the query to refetch whenever the chain ID is changed as well. So yeah, basically that's only the last additional stuff. And now let's start deploying our dApp into the Moralis server then. So yeah, let's start hosting it. To do that, it's gonna be very easy. First, let's build our production app. So to do that, basically just yarn build, or if you want, npm run build. In this case, I'm going to use yarn to build the production version of your dApp. You basically don't want to use your development version because it's not optimized. So just yarn build. It's gonna take a few seconds for some people, but could also be a few minutes depending on your machine. And now it's done compiling the build version for my computer. And if you'll be able to see here the build folder under the root folder here created, where basically this is all are the optimized version of our dApp compiled into one folder. So once that's done, the only thing we need to do is basically to use the Moralis admin CLI. And if you don't have a Moralis admin CLI yet, basically just go npm install globally Moralis admin CLI. And I of course already have it, so I could just kind of cancel it. So here, basically there's a bunch of functionality here. If we type Moralis admin CLI and help, and the one that we need, as we mentioned before, is going to be the deploy one, because we want to do some static hosting for our dApp. So to do that, we are going to Moralis admin CLI deploy help to see the instruction of how to use this command right here. And as you can see, basically it requires 3 parameters, which is the Moralis API key, the secret, and the subdomain. But we can basically provide them directly in the .env file that we set up in the first video in here as Moralis API key and Moralis API secret. I'm not going to show you. You just need to put them inside the your own .env file. But once that's done, basically, make sure that that your CLI is under the root folder. Then we can deploy our dApp. So Moralis admin CLI deploy. And the other thing that we need to specify is the folder that we want to the file the dApp where the dApp folder that we want to deploy, which is the build version, which is gonna be this build folder right here. So we need to specify the path by -p and ./build, and just like that, we just need to choose which server we're going to host this website, and it's gonna be the Moralis betting protocol server. So click this. So choose 0 or 1, and I'm choosing 1 here because Moralis betting protocol. Just like that, and just wait for a few moments, and Moralis will do all the heavy lifting to deploy our dApp into their server. And once that's done, boom, there you go. Our site is now available, and when we click this, we'll be able to see all the dApps that we have. The dApp that we just developed for our DeFi betting protocol. And here, let's authenticate and connect our MetaMask to this dApp, and boom, just like that, we have our betting DeFi platform live on the internet, where people can basically access this site from anywhere in the world to interact with it and make a betting game against other people and win a lot of prize. And yeah, so basically that this is the conclusion of the series. Congratulations again if you have reached this far, because this has been a really long journey, and hope that you get a lot of new knowledge from the tutorial series, and hope the best for your future. And thank you guys again so much for watching. I'll see you guys in the next video. If you guys still have any questions regarding the DeFi betting platform we just built or the tutorial itself, make sure to go to this forum at forummoralis.io, and I'll put the forum link down in the description, and here we'll help you with your questions as soon as possible. Also, make sure to like and subscribe to our YouTube channel if you want to see more Web3 tutorials like this. Thank you guys so much for watching, and I'll see you guys soon. Bye bye.